Welcome to another stream. How about that? How about that? Did you expect that? Did you expect that? Let me guess. You didn't expect that. Let me turn down the music a little bit. Hello, welcome everyone. Hello, Miguel the Diaz, Jiang, Mr. Botka, Aiguduk, Yorunim, Course 69, Katul, NerdyBH1, Aiguduk, Jiang, Zainith, Nipsey. Who else? Herotsen Blots, Super Cuber, Kipras Siltiu, Zeniz, hello, Nitrix Live, welcome Rotten Chumsy, PS Compsci, hello. Welcome everyone to another stream, and today is Wednesday, if I'm not mistaken, and yeah, today I decided to make another stream about virtual machine because I was enjoying making the virtual machine. Can you believe that? I was finally enjoying doing something. That's incredible. In my opinion, that's incredible. So, and yeah, today we're gonna continue developing the virtual machine. You can find the source code of this thing here, and we're gonna start working on that virtual machine. On that virtual machine after I make a cup of tea. So don't go anywhere, or I'm gonna virtualize all of your software. I don't know what to say, but yeah, I'm gonna do something. I will come up with something. Don't go anywhere. Don't go anywhere. Don't go. Hello. Welcome back. So, yeah, as I already mentioned, you can find the source code in the chat by issuing a corresponding command. And let's just take a look at what we've done so far. So I'm gonna start Team Mucus and I'm gonna go to the BM, and what's the status of this thing? We are on some weird branch. The corresponding, okay. Check out master and let me fetch the latest changes. How about that? First try. Fetched the changes first try. Origin master, and should we remove the previous branch? I think we should. This is not the previous branch, and let's build everything. So what we built so far is actually 3 important tools. This one is not that important, it's just a experiment. But our virtual machine consists, like a tool set of the virtual machine consists of 3 important tools. The first one is BASM, which enables you to write in an assembly of the virtual machine. So this is like a non-existing toy virtual machine, and it has its own assembly. So, for example, this is how you write a Fibonacci number generator in this assembly. So, as you can see, it has some instructions, and it has, conditional and unconditional jumps. You can use labels and stuff like that. This is like a proper assembly here, without any preprocessor, unfortunately. Maybe we're gonna add preprocessor. To be fair, do we really need to add preprocessor? We can just use CPP. Yeah. God fucking damn it. Oh wait. Can we use CPP? Because I decided to use these comment things. So maybe that will prevent us. Yeah, so that means we'll have to change the comments. And anyway, so there is BASM, which accepts input and can generate an output. If I go to the examples folder and I try to generate like and try to translate assembly to the bytecode, it will generate me this file. So this is a binary file, right? This is a binary file, and it contains the bytecode of the virtual machine, right? So the next important tool here is BME, which is the virtual machine emulator. So after translating the assembly to the bytecode, you can emulate that bytecode, right? So the thing you have to provide the input, basically the file with the bytecode, and also you can provide the limit, like how many cycles of the virtual machine you want to perform, because for example, Fibonacci number generator is going to go indefinitely and it's going to overflow your stack. So we want to go for a small amount of iterations so it doesn't overflow the stack. And as you can see, it generated us the Fibonacci numbers. So this is how it works. On top of that, there is the third tool, which is important for the virtual machine toolset, is the disassembly. So it can take the binary file that we generated and generate assembly back. So you see it generated the assembly back. As you can see, it doesn't have any comments, it doesn't have any labels or anything like that, because this kind of information is not preserved when you translate assembly to bytecode. So, but this kind of tool is useful in case you want to inspect the translated binaries, right? So, so far we have only these three tools, and I'm not sure if we need more. And of course, on top of that, the virtual machine itself is a header-only library. So that means you can copy-paste that header to your project and embed that virtual machine into your project and use it, use it there if you want, right? So I would say that there's like four important components, right? It's the library itself and the tools that use this library. So assembly, emulator, disassembler, and so on and so on. Alright, so yeah, we do plan to do JIT, of course, we do plan to do JIT, but not right now because the virtual machine is not finished yet. We are in the middle of designing that virtual machine, so it can do some things, but it cannot do like a whole lot. So yeah, that's pretty much the thing. This is pretty much the state of the virtual machine right now. Why are you still in part 1? People expect too much from me. I'm developing this machine for the third day. This is the third day of the development. Okay, so what were we doing yesterday, by the way? What were we doing yesterday? We were working on assembly specifically. By the way, speaking of, I only started to develop this thing recently. Yesterday, we didn't have comments and labels in our assembly language. Can you believe that? We implemented it yesterday. Like yesterday, it was not a thing. It was literally not a thing. Like this language evolved like within 24 hours. So, and maybe today we're gonna add even more things into this assembly. Speaking of adding more things, I need to create an issue for the preprocessor, right? Because I will definitely forget about it. Comments are the future. Comments are really important for a language, in my opinion. They actually serve two purposes. The first one is enabling pieces of code at compile time, and the second purpose is documenting the code. So they're extremely useful, in my opinion. Like any language should have comments. So, can you make variable length instructions? Yes, I can, but why? So let's put it like this: assembly, some sort of preprocessor, even CPP would suffice, but for CPP we need to change the style of the comments. There we go. So this is going to be the thing that we have here. And to be fair, like, I don't know, like variable length instructions are not useful as, you know, fixed length instructions, because fixed length instructions, first of all, is easier to iterate. Second of all, easier to load and save. It's like literally just array of elements. It's just so convenient to work with. There's already operand and no operand. Yes, but, yeah. But even the instruction, they still fixed length. Even if you have instruction with no operand, it still has the space for the operand to pad things out. All right. Variable length instruction and stack-based machine here. It's fucking genius. All right. So, hello, Soding2S. Welcome to the stream. So let's pour a cup of tea. Well, I mean, I'm not allowed to say that word on Twitch, unfortunately, because it's an insult of some sort. I don't know who insulting that word right now in this particular context, but I'm pretty sure somebody feels insulted, so let's not pronounce that word just in case. So do you recommend... Oh, it's not for me. Okay, so the message is not for me. All right. Okay, so, and another thing that we were working on yesterday is an unboxing. It was an unboxing, and it was kind of interesting. Have you guys heard about unboxing? If you never heard about unboxing, watch the yesterday stream. There's also I also linked an article that explains an unboxing in details. So you can read it here. I don't know who wrote that article. Yeah, if this is a bad person, I don't know them, so don't blame me. Anyway, so, and that was an interesting experience. And I extracted the results of the research into a separate repo, right? So, because I do not plan to use unboxing in my virtual machine. So, but at the same time, I don't want to remove the source code because I actually liked working on it, and maybe this thing is going to be useful in the future. So I extracted this entire thing into a separate repo. So if anyone needs it, or anyone want to learn more about unboxing, you can read it here. But yeah, I'm not gonna use unboxing for the virtual machine, and I'm gonna explain why. So let's actually start Emacs and let's go into the source code. Let's go into the source code. So where is the definition of the virtual machine? Here it is. So we have a stack, and here we have words on the stack, and a word is a 64-bit integer. Infinito, thank you so much for Twitch Prime subscription. Thank you, and welcome to our epic unboxing club. That's right, we're boxing nuns. No, we don't. So yeah, and the idea was, instead of words, I would use NAND boxes, right? I would use NAND boxes, and the virtual machine at runtime would look... Theantonio subscribed with Twitch Prime. Thank you for your Twitch Prime subscription. Welcome to our virtual machine club, I suppose. Welcome. Thank you so much. Yeah, so essentially you would have NAND boxes, and for example, instruction plus would look at the types of the boxes, right? We would look at the types of the boxes and perform the different transformations and so on and so forth, and then put the NAND box back. After thinking a little bit about this idea, I came to the conclusion that it's kind of unnecessary. To be fair, it's kind of unnecessary because you can do the following thing. You can make a word a union where you can have something like as 64, then u as u64, then double as f64, and so on and so forth. And most importantly, you may have something like s pointer, and just keep words like this. Right, and then you would have different instructions, right? You would have different instructions, something like I plus that performs integer sum, and f plus that performs float sum, and basically depending on the instruction, it will interpret these bits differently. Right, so it will interpret these bits differently. And by the way, this is pretty much how WebAssembly machine works, right? So like one sequence of bits can be interpreted both as integers or as IEEE 754 flows, depending on the instruction you're using. And furthermore, with such virtual machine, we can implement NAND boxing on top of the virtual machine if we ever will need it. So the only thing we'll need is being able to interpret a sequence of bits as floats and as integers, and also bit manipulate them. So once we will be able to do that, we can just have non-boxing on top of the virtual machine, so it doesn't have to be part of the virtual machine, which simplifies the implementation and makes the virtual machine more generally useful. So less work to do, more generally useful. You get my idea? So if we don't do that on the level of virtual machine, it's just like better, like, you know, only pros. So, and that's pretty much my conclusion after working on NAND boxes yesterday and also thinking about them today. So yeah, that's gonna be the direction that we're gonna go to. And it's not like I wasted time, by the way. It's not like I wasted time because I was doing a research. So I implemented NAND boxes, gathered some information, and came to the conclusion. So there you go, we can finally close this issue. And before we can close this issue, we have to put the results of our research here. So everything I said, we need to put into the comment and say, there we go, here's our conclusion on this research, let's move on. And we can also create separate issues, like for example, create separate instructions for floating point operations, create separate instruction for bit manipulation, and so on and so forth. And we can create NAND boxing as an example for the virtual machine. Where's your peer review? Well, no, not that kind of research. I mean, it's a research for development. So you get my idea. So okay, so let's actually close this issue. Before we close this issue, I think I'm gonna go and just remove the traces of NAND boxing from the repo, because we still have this NAND thingy, which is not needed anymore, of course. So I'm gonna create like a separate branch. And the branch is gonna be 4, and this is where we're gonna remove all of this. So I'm gonna start by just removing this file. We don't have to worry about losing any source code because I already extracted the source code to a separate repo. If anyone is interested in NAND box implementation from me, here it is. Yeah, it's still there. It's still on GitHub. I might have breathed in a little too much bleach fumes. Are you okay? Do you feel dizzy? Do you need to call an ambulance? Are you okay? A little itchy. Oh. Be very careful with bleach. It's actually dangerous. Alright. Okay. So yeah, let's try to recompile this entire thing and see the places where we need to make any changes. So specifically, I need to remove the NAND from the build process as well. Okay, looks cool. And another thing is that we need to remove it. All right. Looks okay. So we also have untracked files which we have to remove from here, and yeah. Move NAND box implementation to a separate repo. Hello, Morning Bird. Check out my FAQ. Thank you for asking this question. It's such a good question. I really appreciate such good questions. Okay, so we moved NAND box to a separate repo, and let's push that branch to the main repo. Right. Okay, so I'm gonna create a pull request. God damn it, I don't have a CI. I don't have a CI. Just copy one from Lisp. Yeah, sounds like a good idea. So, and maybe we're gonna set up CI right on the stream. I think it would be a good investment of time. And I removed 111 lines of code and edit one. Which line did I add? I don't think I added much. What was the edit? Ah, okay, so I replaced one. I see. So yeah, it was a change. God damn it! I forgot to fix my boat. Oh god damn! I have no time for anything. Oh. Belgiano subscribed at tier 1. Thank you so much for your subscription, and welcome back to our epic virtual machine club, I suppose. My god, like I keep forgetting to do things. Like I have so much stuff to do, like on stream and off stream. Just tell us the password, chat will fix it for you. Okay, I don't know, we'll see. Hopefully I'll not forget to do that after the stream. I'm really sorry. Alright, so I'm gonna merge that, and there we go. We don't have NAND boxes. Okay, so I need to close this issue now, right? But first I need to put the comment with the research results. I'm clicking on this thing, it doesn't go anywhere. Okay, finally. Okay, so looks good to me. After doing a little bit of a research on NAND boxing, boxing, I came to a conclusion that it is completely unnecessary to implement it on the level of the virtual machine, right? So if we had okay, we just need separate instructions for integer and floating point arithmetics, instructions for bit manipulation, separate instructions and instructions for bit manipulation. Okay, we just need separate instruction for if we had, first of all, separate instructions for bit manipulations, we could simply implement the NAND boxing on top of the virtual machine in the application itself. This simplifies the design of the machine and makes it more generally applicable. Does it make any sense? Does this make any sense? After doing a little bit of research on NAND boxing, I came to a conclusion that it is completely unnecessary to implement it on the level of the virtual machine. If we had separate instructions for integer and floating point arithmetics and instructions for bit manipulation, we could simply implement the NAND boxing on top of the virtual machine in the application itself. This simplifies the design of the machine and makes it more generally applicable. Manipulation. There we go. Cool. Looks cool to me. Arithmetic. What arithmetic? Is it arithmetic? Okay. So why is it virtual machine? Don't ask silly questions on my stream, please. All right, so after the, so looks good. So, and we are ready to actually close this issue. There we go. So next time somebody asks on the stream, but what about NAND boxing? I remember that yesterday, Zozin, you were implementing NAND boxing. Where is NAND boxing? If somebody starts doing that, just send them this link. And just tell them to read this comment, please. So maybe at some point we're going to create a special command or something, and we will see how it goes. But for now, this is the basically resolution of the NAND boxing research. The NAND boxing research. So Oh, and by the way, I think since we said that we need separate instructions for floating point arithmetics and instructions for bit arithmetics, well, it makes sense to create issues for that, right? So let's go ahead and create issues. It's getting a little bit hot in here. I think finally the weather becomes better in the Novosibirsk. So I probably will have to actually change my clothes a little bit. Yeah, it's actually -7 and it's a little bit hot in this sweater. Alright, so changing clothes in the middle of the stream, question mark? That's the content I subscribe for. Alright, so, and let's go to the master and, yeah, let's see. Master. I tried shaving my head with one of those metal razors with the replaceable blade, and now I have cuts all over my head. I didn't know, like, I rarely cut myself with the razor blades, even especially if I, like, shave my face and everything. Like, it's just rarely, like, very rarely happens to me. I don't know why. Maybe there's something with my skin or something, I don't know. Hope you're okay, Belgian, by the way. My skin is too smooth, maybe, I don't know. Please be careful, Belgian, with this kind of stuff. Alright, so you're good, okay, nice to hear that. Nice to hear that. Okay, so did we fetch the stuff? This is for compiling your Lisp code down to bytecode, pretty much for that. It's really hot in here, I need to change my clothes. Okay, let me switch quickly to a t-shirt, because holy shit. I didn't expect to be this warm today. Okay, so just a second. Yeah, have fun. Yo, what's up? Welcome back. So yeah, -11 is a little bit hot in Russia, yes. I came, exactly. You're goddamn right. Okay, so as already mentioned, we need separate issues for everything that I mentioned here, right? We need an issue for floating point instructions, and we need a separate issue for integer instructions. Right? Not integer, but bit instructions. Separate instructions for floating point arithmetic, and we're gonna say derived from issue number 4. There we go. Yeah, I really like this color actually. It's actually pretty cool. Is the central heating at a fixed temperature? They probably didn't adjust it correctly. Yeah, probably. So essentially, maybe they just didn't expect that temperature at that time of the year, because we do have like -40, but it's usually like after the new year, not in December, like it's January or February. So it's just like probably caught everyone off guard. So, and the infrastructure wasn't really ready for that temperature yet. And it's definitely at fixed temperature, so you can control it. So, yeah. So this is one, and another one is going to be separate instructions for bitwise operations. Separate instructions for bitwise operations. And it's also, in fact, derived from the 4th issue that we closed, not the 10th one, 4th one. Thank you so much. It was the 4th one. Not 4th programming language, but a 4th, issue. The issue number 4. And I guess that's cool. 4th one. Yeah. It's an interesting language. It's kind of sad that I didn't have an opportunity to try 4th on Advent of Code, but yeah, at least I tried assembly, which was pretty cool. So what we're gonna work on? I think I'm gonna start working on separate instruction for floating point arithmetics. So, and we'll see how it goes. Right now, have you ever been to a warmer country where temperature is in positive 20s? Yes, it's called Russia, and I've been in a city called Novosibirsk. So, okay, here's the thing for some people who never been to Siberia or Novosibirsk specifically. It's a very strange place where the temperature throughout the year jumps between -30 to +30. Yes, it's not a fucking joke. It's -30 in winter and +30 in summer. It's a horrible place, I'm telling you. So yeah. So summer is unbearable, winter is unbearable. Holy shit, I wanna die. Anyway, so, and every year it actually gets worse and worse, trust me. For some reason, I don't know why. Maybe the time has come to finally move out of here. Yeah. So we're gonna start by creating this thing, and let's go. You were born... Well, was not necessarily born here, but... I mean, technically I was born in Siberia, yes. Technically I was born in Siberia, but I wasn't born in Novosibirsk. I moved here some time ago. Have you tried Pascal 2? Yes! Check out this repo. Look. Check this repo out. So here's the repo with all of the solutions for Advent of Code 2020 we had this year. And all of the 25 languages are here. So if you're interested, if I tried a particular language, just do Ctrl F and type the name of that language, and there you go. The 15th day was solved in Pascal. So furthermore, we even programmed in Ada. If you're a Pascal fan, you're probably also an Ada fan. So we, in fact, were programming in Ada. It was an interesting experience, I'm not gonna lie. NeoFetch? No, NeoFetch, you have to subscribe for NeoFetch, I'm sorry, Comfort Wishes. It's not a free service. NeoFetch is a cost subscription. I'm joking. By the way. It's a joke, by the way, it's a joke. It's a joke, but I'm not gonna do that anyway. Anyway, let's continue. So how are we gonna start all of that? I already mentioned that I want this word to be like some sort of union that you can reinterpret however you want, right? Never mind, I was crying anyway. Good. So here's the thing. So the thing I'm thinking about is essentially create a union. But I heard that using unions like that is undefined behavior. Is that true? I think it is true, because like, yeah, you're essentially reinterpreting, and the compiler can do all sorts of optimizations. Not in C. Oh, it is in C++. Okay, in C it's totally... Thank you everyone. I'm really happy that I decided to use C today. I'm super happy. So, and that means we can do a shit like uint64t, right? As u64. It's a problem in C++ because object life... Yeah, okay, object lifetime actually screws everything up. C3301, thank you so much for tier 1, for gifting tier 1 to the Zozin community. Actually, to come forth fishes. Thank you, and welcome to our epic NeoFetch club. We like to do NeoFetch. And I just issued NeoFetch not because the Comfort Wishes got a subscription, but because I like to do NeoFetches. I just love to do that, regardless of anything. Okay, it has nothing to do with subscription. I do not do like any rewards based on subscriptions, bits, or anything like that. I just like to issue NeoFetch once in a while. Hello, Gail Lolo, welcome to the stream. Sergio, hello everyone who just joined. So yeah, isn't that cool? NeoFetch is actually pretty cool. Look at that. So yeah, I use Intel i5, the very old one. What happened to the hair? Well, have you read the title of the stream? Okay, so this is what I plan to do here, and also we're gonna have something like as S64. Okay, chat. S64 versus I64. Fight. Oh yeah, we have polls. I forgot about that. Okay, so how do you use polls? Okay, so it has to be it has to be poll. Then 30 seconds. Then I think it has to be something like I64 versus S64. Yeah, there we go. We have a poll. Cool. You have to issue a number. So many people participate. Jiang, it's not counting extra. Jiang, stop. Jiang, stop. It doesn't count extra. It doesn't count redundant ones. It's not gonna work. Okay, I64, sure. So it's gonna be I64. Thank you everyone, thank you, I really appreciate you. So, and another one is going to be as F64. And so far I don't think we need anything but as pointer, right? So that should be okay so far. That should be okay. And on top of that, I think we need some special functions like frame U64 that enables you with just constructing things this way, right? Then I64, which is that, then F, which is going to be a double X, and then we're going to have a frame PTR, which is just a void, and yeah, we'll just have to create all these things like that. Yezu. To be fair, do we really need to do that? Because at any point, if you want to create a frame, you can just do designated initializers as U64 and just assign whatever the fuck you want there, right? Like this. I think it will work. Designated initializers with unions and shit like that, so yeah, that should be okay, I think. So I'm not gonna try to create something unless it's actually needed. And by the way, since it's C, we want to have like a type def here, because I mean the C will force us to prefix this with union. Frame, F for double. Well, I mean, yes, double is a floating point number. It's a 64-bit floating point number. Do you have any problems with that? Do you disagree with that reasoning? So, in my opinion, it's just the naming of the variables in C is dumb. Right. I would rather prefer F32, F64, and so on and so forth. Right. So, because I don't want to remember what float means, what double means, what int means, what long means, what long means, what long means. Like, why do I have to remember that? Just give me the amount of bits in your goddamn number and I'm gonna be happy. So, I thought double was two numbers. Well, it has a double precision. It's not really two numbers, it's a double precision. By the way, does stdint like have you know, aliases for floats? Probably not, because why? What does it do in stdint? No, it doesn't have that. But do you have std float? Do you have std float? Haha. Interesting. Yeah, people are talking about that, yes. Float 32, float 64, float 69. Since your question is tagged C++ as well, I'm going to suggest boost integer. This, I don't know how to react to that, but this is the wording is perfect. Okay, I love the wording. Wording is just fucking perfect. Since you didn't say that I cannot do otherwise, here is boost. Okay, so we have a stack and we're gonna have a frame on the stack. Cool. Here's the frame on the stack. And I think stack size has to be something like... And I also want to get rid of the word, of the notion of the word, because I don't think it's that useful. Link with boost now, but you not always have to link with boost, do you? Because you can... So there's a lot of header-only libraries there. By the way, I have an epic idea, chat. What if the operand can also be a frame? Yay! So you can interpret it as a frame, as a float. It depends on what you're gonna put there. What lang is this? This is C. This is a pure C language. And I think the name of the language is in the title, so I'm not sure why you're asking. But yeah, it's C. It is in fact C. What's up, bit69 trim? So I'm still thinking, do I really want to call it word? Because it's kind of interesting, because I still want to reuse the same type for instructions, right? Because the type inside of the instruction can be interpreted differently, right? Can be interpreted differently, but at the same time, like, I have to use word for the stack size, and for some reason I have an opportunity to interpret stack size as pointer or double, which doesn't make any sense, so I think I will have to do something like this. I think it makes more sense. Yeah, I think I'll have to do that. But this is a word, and it enables you with doing this kind of thing. It cannot be pure C, it's suggested to use boost. Haha, very funny. What is the idea here? Are you writing your own CPU architecture or something? I'm writing my own virtual machine, architecture of a virtual machine that I'm gonna use for my scripting language in the future. And also I'm learning how to do that. I never implemented a virtual machine before, so I'm definitely learning how to do these kind of things. I think it's cool. So, and of course, we're gonna have a stack of words. Of course, we're gonna have that. Oh, by the way, I forgot to check a very important thing, chat. Main.c. I forgot to check. What's the size of this monstrosity? So it's gonna be LD size of word. What's the size of it? If the size is 8, I think we can say that we succeeded. Right. 4? Where did you get that number from? It has to be 8. It has to be 8. I'm on 64-bit system, right? I think it's a 64-bit. Yeah, it's x86-69. You see, x86-69, and so that means the pointer is 8-bit. Double we know is 8-bit, and we can clearly see that it's 8 byte. We can clearly see that the size of these values is in the name of the types. Use static assert. Yeah, sure. By the way, static assert. In C, we do have static assert because according to the standard, C provides the macro that redirects to underscore static assert. So we don't have to worry about that. Everything's okay. But on top of that, I want to actually clearly see. I want to clearly see the size of it. So let's try to compile this thing and save everything. I couldn't actually do that because I forgot to include stdio, stdlib, stdint, std your mom. I think this one is unnecessary. I think it's too big of a header to include into our small program, so I'm not going to do that. So if I run this thing like this, yeah, there we go. It's 8. We won. Chat. We won. Zoom. Can Yoi lower a bit the lo-fi music? Maybe I can. I think it's a little bit too. Yeah, you're right. It's a little bit too high. All right. So it seems to be working. Seems to be working now. I think we can add static assert somewhere here. Static assert, size of word equal 8. The BM's word is expected to be 64 bits. Right, so this is basically the static assert that we have here. We do include static assert here, and basically you won't be able to build BM on 32-bit machine. So I'm thinking, do we want to support like different modes? Maybe BM is going to be like 32-bit BM, 64-bit BM. You know what's funny is that WASM supports that. So there is like a 32-bit mode in the, I'm not sure if it's a mode, but yeah, there's 32-bit WASM, there's 64-bit WASM, and they separate that just in case. So yeah, I know, but I mean, maybe we can implement that in the future. It's like you make it sound like just because I put this thing here, it's absolutely 100% impossible to remove that and put some conditional compilation here in the future. I mean, come on, dude. So this is not what I'm asking. All right, so we're gonna go with 64 bits, and we'll see. Forcing BM to my keyboard microcontroller. Yeah. All right. So let's see if it's gonna compile. It's definitely not gonna compile because I changed the definition of the word, so it's not gonna work anymore. Okay. So I'll have to go through all of these things. Oh, that's actually pretty interesting. So since IP now is negative. So IP could be, so I made IP uint64. I made IP uint64. So what I'm thinking is it okay for IP to be unsigned? I think yes, because I'm not gonna have like negative instruction addresses. So I'm gonna quickly remove that, and I'm gonna continue doing this thing. I'm working on the virtual machine. So I don't know, can we have like a link on what is a virtual machine? Okay, let's actually take a look at JVM. What is a JVM? So Java virtual machine. We're not working on Java virtual machine, but we're working on a virtual machine. So we're making our own virtual machine. In computing, a virtual machine is an emulator of a computer system. Virtual machines are based on computer architecture and provide functionality of a physical computer. Not necessarily. Things like JVM, for example, they emulate a non-existing machine. They're just emulating some abstract machine. And what's the point of having, of emulating an abstract non-existing machine? Well, that if you implement that machine on different other machines, programs that implemented for your machine will work on all of the places where that virtual machine is implemented. How about that? It's the famous compile once, run everywhere. It's the famous compile once, run everywhere. So that's exactly what we're doing. We're creating a virtual machine, a non-existing machine. You write program for that machine, and your program works on all of the other real machines for which our virtual machine is implemented. Isn't that amazing? That's what we're doing. We're implementing our own virtual machine. Why, you may ask? Because we can. Yes, because we fucking can. Yes. And check out the source code. So it's completely open source. You can check it out here. We only started. This is the third day of implementing this virtual machine. Here we go. Does it make sense? Does it make sense? Does it explain anything? What part are you working on right now? I'll check out the source. I don't really know what part I'm working on right now. I'm just I'm adding more instructions to the virtual machine. You know, any machine or any CPU architecture, they have like instructions. And we already have a bunch of instructions. For example, we already can generate Fibonacci sequence. I can show you how it works. So here is a program. Here's the bytecode of the program that generates Fibonacci sequence. So here's the program, seriously. And we have an emulator of our virtual machine. And if I run it, it generated Fibonacci numbers. So basically these numbers were calculated on our virtual non-existing machine. Seriously. And the assembly of that machine looks like this. So this is assembly of a non-existing virtual machine. So it doesn't exist. We created it from scratch essentially. And this program calculates Fibonacci numbers. So that's what we have so far. This is basically the instructions we have. We actually have a little bit more instructions. We don't use all of them. But what we're working right now, we're just making the machine more powerful. We're adding more and more features to the machine so you can write more powerful program in it. And then you can, for example, create a compiler that compiles the source code, for example, of C to this virtual machine. Emacs question. I'm sorry, I don't answer Emacs question. I can suggest you to use Visual Studio Code. When you switch to another branch, how you update the branch information in mod line? I don't know. I don't do anything. I'm sorry. I just switch to another branch and it just does the thing. Don't worry about it. Just use Visual Studio Code. Seriously, like, come on. Why do you have to use that old ass editor in 2020? Seriously, come on, just download this thing. You're gonna thank me later. Seriously, just use that. Come on, don't even worry about that. Old ass boomer editor. Who fucking uses it in 2020? Seriously. I think this question was serious. My answer was serious as well, by the way. I don't know. Yes, this is my answer. I don't know. It just happens. Like, I didn't do anything about it, so what do you want from me? Here's my serious answer. I don't know. Okay, let's continue fixing the code. And I also being serious, like, don't use Emacs unless you're already using it for a long time. Just don't waste your time. Use like a proper editor. All right. So I think now you see we're trying to modify these frames. And we are interpreting them as essentially as U64. Yeah, this is what we're doing here. We're interpreting them as U64. There we go. What else do we have? And goddamn, and I think we'll have to do that pretty much on each instruction. We'll have to do that on pretty much each instruction. Isn't that amazing? Is it in Emacs just because he can't exit it? Exactly, actually. So the reason why I use Emacs is because I got into it a long time ago and I already developed a shit ton of reflexes and I know how to solve majority of the problems in it, so the cost of switching to other editor is just enormous. It's a shitty editor, but switching to something else for me is just too much of a waste of a time. So that's why I keep using it, and that's why I don't recommend to anyone else to use it, because don't invest your time into this editor, because once you invest your time, you won't be able to go back, because you already invested too much time, so you won't be able to uninvest it to something else. So that's why I do not recommend this editor. It's trash, and yeah, don't waste your time. And I'm not even joking, I'm not even trolling or anything, I'm just warning you with my experience. I invested my time into Emacs so you don't have to. So you can be free and use whatever editor you want. I sacrificed myself, my time for you so you don't repeat my mistakes. Why don't you understand that? Anyways, So, okay, what do we have here? So if we have a division, we know that it's a integer division. So this is what we have here, and we're going to throw an error div by 0. So here's another division as u64, as u64. Okay, so here's an operand, and when you jump, okay, so when we're jumping, we're actually interpreting an operand as u64. I really like this word thingy, because you take the operand and say, okay, interpret it as u64. It just works, and IP is u64, pretty much. It's pretty nice, I really like that. Okay, equality, so what we're doing. Okay, so can I do something like as u64, but then I'm gonna compare the unions? Is it possible to compare them like that, bit by bit? It's actually not possible to compare them like that. I might as well just do it like this. Okay, so, okay, jump if. Makes sense. As u64. And this one as u64. Okay, cool. All right, so as u64, this has to be something like LLU. So this is like a special debug instruction that prints the numbers on the screen that I never used in my entire life. I don't know why, but it's just, it is what it is. Long unsigned int. Oh, it's a long unsigned, okay. So, but wait a second. Isn't uint64 not long unsigned int? Is it not? LLU is on Windows. Interesting. Wait a second. It's kind of strange. So if I go to here, like I'm kind of confused. On some systems it's LLU. So because I thought like long is 64, right? Size of int is going to be uint64 underscore t is going to be equal whatever, like ld size of uint64t, and let's actually put it like that. And long unsigned int. That's what classic C, by the way. Classic C. And god damn it, this I didn't want to CMake, and let's do gcc main.c and let's execute this thing. And what is gonna tell us? It tells that both of them are equal to 8. Both of them have the same size, but they might not technically be the same types, right? Also, I have like very strict flags, but I can see, okay, so on there is a guarantee for uint64 that is going to be exactly 8 bytes. I have a feeling that there's no such guarantee for long unsigned int, right? So on all of these systems, that's probably the problem here. What's the point of even having? Shouldn't printf command be able to figure it out with the universal format character? What is a universal format character? Oh yeah, it's not able to do that with the universal format character. You know why? Because of the variadics in C. So essentially, variadics in C are so scuffed they lose information of the arguments. It's not a joke. So you don't know the types of the arguments when you do variadics in C. So essentially, to know their types, you have to pass them somehow. Printf achieves that by using different characters here. So through these characters, the function printf knows the types of the arguments, and since it knows the types, it knows the sizes, so it can precisely calculate them from the stack, because I think they are passed through the stack. So it's a flaw in the design of C. There is no workaround of that. So that's what. Does it make sense? Does it make sense? It's actually kind of sad that it's impossible in C, but just it is what it is. It's a very old language. This language was designed in 1970. 50 years. This language is 50 years old. We're still using it. Type of, well, I mean, it needs to figure out type of this variable at runtime. Things like type of, I don't even know if C has it. They usually can do that at compile time. It depends on what you mean. So yeah, all right, but they seem to be different types. So if I have something like uint64t and I have it as 69, and then I have a long unsigned int y, and I'm gonna assign x. GCC has a type of GNU extension, and I'm pretty sure it's a compile time feature, but printf needs the type at runtime. That's the problem again. So it needs to know that at runtime. Oh, god damn it. I cannot copy paste anything because Chaturina. Referring to a type with the type of, another way to refer to a type. It's a compile time feature, yes, obviously. I work another way on Friday? No, we're gonna do a random one-off topic on Friday. Okay, so if I try to compile that, will that work? And unknown type, yeah, so let's actually fix that. Okay, so, but on top of that, I also have these kind of flags. Extra. Okay. Okay, something really strange, like I didn't... Okay, maybe I just didn't read the error of the compiler in my project properly yet, so that happens quite often actually. That happens quite often. Okay, I want to make a cup of tea before I continue refactoring my project. Does anyone have any questions while I'm making a cup of tea? Compiling with Clang. Oh yeah, I haven't tried to compile a virtual machine with Clang. Thank you for reminding me about that. Why don't you use CMake or Make? Because CMake for this specific project is an overkill. So right now, I literally have 4 files. So using CMake for this thing is going to be overkill. And it doesn't have any dependencies, by the way. Especially for the projects that don't have any dependencies. Well, except libc and libm. I do depend on libc and libm. It doesn't have any other dependencies, so it's definitely overkill for such a project. Have you considered writing BM and Rust? I have, but I decided not to. How did you parse the instructions in the bbosom file? Manually? So I'm not using any third-party dependencies, any parser combinators or anything like that. I actually parse them manually. Again, you can check out the source code of the project here, and it's located in bm translate. Yeah, there we go. So find the function bm translate source code. Yeah, so it accepts source code as a string view. What I'm doing here, I'm iterating through each individual line, chopping the line out of the source code, and then parsing the line accordingly. I extract the label if it's a label. If it's not a label, I extract the instruction, and depending on the instruction, I actually append the instruction to the program or not append the instruction to the program, and so on and so forth. So this is the entire basically assembly that translates the code, and it's around 75 lines of code. It's not that big actually. This is the whole assembly here, so it's super simple. All right. Yeah, the difficulty of parsing is actually kind of overrated. Parsing is way easier than academic people try to present it, in fact. I don't know why. It's kind of strange. Does anyone have any other questions? I'm just making a cup of tea, so I'm open to read some questions. So it's the error message that are hard, lots of menu. Yeah, it's true. That's why error messages for this assembly are kind of crap. So because I don't even keep track of lines, by the way. So I think, oh yeah, I think we need to create an issue for that. Thank you for reminding me. Okay. So let me create an issue for that. I'm really glad that we started to discuss that, because yeah, I just realized that we have a problem. Okay, so assembly. Error messages. Compile error messages. Don't keep track of the lines of the position. I think that would be a little bit better. So it would be better if they keep track of the position, so every time an error occurs it would also tell you where exactly that error has happened. I think that would be actually lovely. But we don't have that right now because we just, you know, hacked everything together. Why are you writing a VM? Why are you asking silly questions? Don't ask silly questions, because I can and because it's fun. That's the answer. Come on. What other answer did you expect? Seriously? You can introduce a macro with line and func. Why? Where can I use them? They are needed to locate a place of an error within your C code. Or maybe I'm missing. Right, so you can use them to actually tell you where error happened within the C code, but we don't need this kind of place. We need to know the error within the bosom code. We don't need the position in the C code. C code is just C code. We don't care about it. We want to know where the problem has happened in the bosom. Yeah, I was talking about bosom code, of course. So if I make a mistake, like in here, I want the bosom translator to tell me at least the line where the problem has happened. So yeah. I'm new here and newer to programming in general. Oh, okay. Very well then. So what we're doing here, by the way, for new people, is recreational programming. That's what we're doing. So that means we're doing programming for the sake of programming, because we like to do that and because we're having fun. So we usually pick a programming topic and we just do it because it's fun and interesting and we want to learn something. So there's no like really much pragmatic aspect to what we're doing. It's almost like 98% recreational. We're just having fun. A question from someone who doesn't know anything about VMs. I also doesn't know anything about VMs. It's actually pretty cool. How do you sandbox your VM but you allow it to run code on CPU? Well, we just don't allow to run it on CPU right now. I haven't researched that topic yet. We can get into that when I start doing JIT, and maybe then I will be able to answer, but so far I didn't get into that, so I don't know. Have you done any other after AUC off-screen? Yes, I programmed a little bit in other off-screen, not on the stream. Alright, so I need to go to the kitchen because I need to turn on the kettle for my tea. So I'm gonna leave the stream for a couple of seconds. Don't go anywhere, or otherwise I'll ban you from this channel, okay? So my bot automatically detects if you close the tab while I'm being in the kitchen. Insta-ban. Insta. So, don't go anywhere. I'm gonna be back pretty soon. And then we're gonna continue developing this virtual machine. Alright. Have fun! Have fun! Hello, welcome back. What's up, Epic Gamers? I thought you were going to make all my variables constant if I close the tab. I already did that. Okay, shut. Oh, Lembakota, what's up, Lembakota? Hello. Hello, Daft Maple, Carrot91, Draco, Genuinely Deceptive. Hello, hello, welcome everyone who just joined Craftwork, welcome. Okay, so we're trying to make our stuff compilable, right? So, yeah. What do you feel are the limits for your instruction set? RISC clips, are you adding any multi-cycle instructions? I don't know, I'm still researching. Like, I don't really have, like, end goal so far. I'm just, like, adding instructions and see how it goes. So, let's try to compile this entire stuff. Okay, so I have a stack size and invalid operand uint aka word, so that means I need to cast it to 64. What's the next thing? Oh, this one is interesting. So if we are duplicating, we're duplicating a particular... That's cool. So since we're interpreting always like these addresses as U64, there is no illegal operand for dupe anymore. So that's quite important. There is no illegal operand for dupe anymore. Okay. So here's the stack size. We do -1 and the operand as U64. Another one. Cool. So here's the special function that dumps the stack of the virtual machine. So what we're essentially doing here, we can just do uint64t. There we go. We don't have to do a word anymore. Okay. You know what I'm thinking? What if we try to dump it as all of the possible values? Like, for example, as use, because you never know how to interpret it, right? So we can do something like LLU, then as LLD, then as LLF, and then maybe as a pointer, right? It's because you never know how to interpret them, and we can just, you know, print them as everything. Again, maybe it has to be LU, but I'll let the compiler to decide how to interpret all of this. So it's gonna be I, it's gonna be F, and it's gonna be PTR, right? Something like this, and let's see how it's gonna go. And it's gonna be on the same line. I think it's gonna be actually pretty convenient in my opinion. All right, so it has to be L, right? So it has to be L, and this has to be L, and then the pointer. Okay, so another thing. So push label, right? We're doing bosom push label, and it accepts the address, and this is an instruction address. And maybe we need to be able to separate an instruction address and so on and so forth. I have not decided that in 64, because we have pointers which point to like a real world memory, and we have addresses of the instructions. So maybe we need to somehow separate them. How does the as union work? Is it the union? Yeah, it's union. I can show you, by the way. Word. There we go. So here's the word, and you can basically interpret it as these four entities: unsigned 64, signed 64, floating point 64, or as a pointer. And then on the virtual machine we have a stack of these words, and depending on the instruction, different instructions just interpret that word differently, right? Make sense? Hopefully that makes sense. Yeah. Too bad C doesn't support closures. If it did, the stack would have operations like add operands. Probably. I don't think it's that needed. It's kind of redundant. You can do that. If you can do the thing without it, like why bother then? It's just redundancy. uint64t. Okay. Alright, so we have missing braces around the initializer. Oh. Do I really need braces here? It's kind of strange. Oh yeah, in a label. In a label. Where is the label implementation? By the way, label is a very crucial type for our assembly. Oh, Saramun, hello. Welcome to the stream. How are you doing? So, and this is what we're gonna have here in 64T. There we go. Yeah, because to translate assembly, we have to keep track of the labels and stuff like that. Okay, so I think my tea is ready. I'm gonna go to the kitchen and brew up my tea. Don't go anywhere, or as I mentioned, Instaban. Instaban. Motherfucking Instaban. What? Bad. Permanent bad. Hello. Yep, here's my tea, by the way. Okay, go. Let's continue compiling. Cool. So we have an address here, and find the label address. I definitely need to introduce like a type def. So essentially I want to have something like type def uint64 instruction address, right? An instruction address. That's what I want to have here. Right, so even though it's not gonna properly type check anyway, at least it's some sort of a documentation, right? It's some sort of a documentation, what function like expects, like a semantical documentation. All right. So on stack size is that program, and program size could be instruction address, but maybe not. Oh, and yeah, by the way, like IP could be just an instruction address to indicate, you know, what, excuse me, what it is, to indicate what it is. So in a majority of int64t places where we use them, it could be just an instruction address, because a label, right, it's a name that points at a particular instruction address, and deferred operand is basically an instruction address of that operation with the label it refers to. Yeah, there we go. So let's actually find other places where we use that. Yeah, there we go. It has to be instruction address. So stack. So this is, well, technically it also has to be an instruction address because we're iterating the stack. So I is technically an instruction address. IP leaked. Haha, very funny, very funny. Okay, instruction address. Is there anything else? And push label also an instruction address. Instruction address. And that's it. I think I actually addressed everything. So let's actually continue programming. I mean compiling. So what is it? Conflicting types. Yep. Ah, I see. So it's an instruction address. Cool. So push deferred operand, it accepts an instruction address yet again, and the function here should also accept the instruction address. There we go. Cool. Missing braces around initializer. Ah, I know what it's all talking about. Because svn to int, yeah, svn to int returns svn to it returns integer, but operand is a word now, so that means you have to do the following thing. Okay, so we're gonna do it like that. As I64 equal to sv to int. So this is basically what we have to do now, right? So because operand is this thing. All right. So, and here is another one, so we'll have to repeat it like this. As I64, like that. Sure, Zhang, sure. As I64. Also, we need to add support for floating points on the level of assembly. That's something that we'll have to do, chat. Because right now, our assembly supports only integers. Who's Jiang? Your father. Alright, because as you can see, it's only integers. So I think my tea is ready. So we are ready for a little bit of a TSMR. No. Damn it. Sodium, you got an issue, better. You've got mail. Sounds like a threat, to be fair. Let's take a look at the issue. Is it something about alignment? Deferred spelled wrong. Okay, thank you. I mean, feel free to submit the pull requests. Something strange is going on. All right, let's continue. So, yeah. But we might, okay, thank you, by the way, because I can fix it right now while I'm going through the compilation errors. This is actually perfect. Deferred, yeah. I might as well actually do it like that. Query replace this. Yeah, it's just easier to do that myself. Cool. And also this one. Let's query replace deferred. Yeah, double R. Boom. Okay, cool. So what we have here, invalid initializer. So this thing has to be instruction address. This thing has to be an instruction address. And what's that thing? This is the operand. Okay, and that means that this has to be as U64. And there we go. Sublime cannot do that. Well, it's too bad. I guess Sublime is not a God editor, after all. Okay, good. So here's the LDD. So this is the operand. That means we have to. So when we're generating this thing, I'm just thinking, it has to be as I64. As I64. As I64. We're almost there, by the way. There we go. We did the refactoring. So now Word in our virtual machine can be easily reinterpreted as one of these four things actually. And the next step is going to be adding floating point operations. What's the case matching replacement, like the Vim Subvert plugin? Case matching, I don't know what you mean. You mean query replace? It's actually like a... Oh, case, it's actually a built-in feature. It works by default like that. Alright, so I think we're ready. We've done a lot of refactoring here, and to be fair, everything is built. Let's try to build the examples as well. Let's try to build the examples, and examples are built correctly. Would you look at that? So I'm gonna do fib bm, and then I'm gonna do debusm examples fib bm. So assembly and disassembly still works correctly, which is nice. What about 1, 2, 3? Yep, still works nice. And let's take a look at the emulation. So we're gonna try to emulate Fibonacci example, and we're gonna limit it to 69 instructions. There we go. This is what I want you to see. Isn't that cool? So now on the stack, you can see the value being interpreted as signed, unsigned, float, and pointer. So yeah, that's pretty cool. Maybe it would make sense to somehow indicate what they are, because it's kind of like not clear. So dump stack, where is the dump stack? So here you can do U64, then I64, then F64, and then PTR. There we go. And if we try to recompile all of that, and if we try to emulate that, well, it didn't really recompile everything properly. There we go. Yeah. So we can now see how they are reinterpreted. So if we try to interpret them as floating points, they're always zero, so they don't mean anything. It's pretty cool. Wouldn't the register-based VM make AOT easier later? Maybe. I don't know. We are still researching. This is the third day of developing this virtual machine. I don't know nothing about virtual machines. We are researching. We don't have enough information to ask such questions. Okay, so I think we're ready to do a committee. Okay. 10. Make the word reinterpreted. Did I spell it correctly? I spell. Okay, so I think it's okay. And interpreted as different values. Also close 13 because we actually fixed the spelling of defer. I'm gonna push that right into the repo. All right. So everything looks okie dokie karaoke. And now the next step, according to the issue that we're working on the 10th issue, and we just need to add operations for floating point stuff. Yeah, floating point arithmetics. To be fair, that means we'll have to rename some of the instructions. Like right now, plus, minus, multiply, division, they are integer values, right? But what we need to do instead, we need to rename them to something like, oh my god, I plus, I minus, and I multiply, I div. You see what I mean? And then we're gonna have another group of instructions, f plus, f minus, f multiply, f division. Plus, please. Why not? Okay. Wait a second. It's kind of difficult to do that, but I can try. So if I select this thing like that and query replace this thing like this, so we can do it like that. Then I can get rid of this thing and query replace this one more time, but instead of f is I. Is that better? Plus I, minus I, mult I, div I, and so on and so forth. So for now, I think we're gonna conduct the renaming of the current instructions to just from plus to plus I, because that already by itself might take some time. Let's try to compile that. As you can see, a shot. Well, for some of these things, I think we can do simply query replace, so it's going to be inst plus I, like this, in all of the places. Boom. Okay, so another minus I is going to be that, minus I, boom. So this one is going to be mult I, boom. And this is going to be query replace div I, boom. Another one. I see. I was thinking, didn't I just replace everything here? No, it's a completely separate file. I forgot that I have actually several files where I use all this stuff. So yeah. Is this stream posted somewhere? I'd like to follow along with the beginning. Yes, it is posted, and check out the VODs channel. By the way, speaking of VODs channel, I created a separate playlist for the virtual machine. Let me see. Just follow this YouTube channel. It's actually pretty cool. We have everything posted there. Yeah, virtual machine in C. So right now it contains only one episode, right? It contains only one episode. The second one is going to be posted after this stream, and this stream is going to be posted to that playlist tomorrow. So we upload them on the next day. So I actually grouped everything related to virtual machine to this thing. Push I, push F. I didn't think it's that important. Because when you push, right, so instruction push, there we go. So push accept word as an operand. So it doesn't care about the type. What it does, it just pushes a string of bits that you can then reinterpret however you want. So to create an instruction that pushes floats, right, you just have to do instruction push and the operand equal as F64, like this. You see what I mean? So you just have to do that. Yeah, it's the same instruction. You can use the same instruction for pushing any kind of values. Will you comment the code? I will definitely write a specification of the machine when the specification stabilizes. Will I comment the code? I will put as many comments as necessary because I believe in self-documented code, right? So yeah, for example, do I need to document this thing? It's a union word, so if you know C, you will instantly understand that it's a word that can be reinterpreted in 4 different ways. That's it. You don't need a comment for that. What kind of comments do you expect? I'm not really sure. So yeah, I'm just trying to come up with as many types as possible, so the code is just self-explanatory, right? So I don't know what to comment here. The comments are usually needed when there is some sort of a hack that is difficult to justify, so you need to put a comment there. But apart from that, if the code is self-explanatory, you don't really need that much of the comments, right? So the names of the functions, the types, the arguments should actually explain you what this code is all about. And also examples, and we have a lot of examples in my opinion. All right, so, but yeah, I'm gonna actually document the specification of this machine in the future once the specification actually stabilizes, because we're in the middle of changing a lot of things. Okay, so everything looks good so far, and I can try to compile the examples. Right, so here are the examples, and what's funny is that we don't distinguish integer operations and floating point operations on the level of assembly, so this is something that we'll have to do. So the bosom example fib bm, yeah, there we go. It's still called push, I mean it's still called plus, and so on and so forth, so we'll have to actually rename them appropriately. Isn't word size hardware dependent? Yes. How does that contradict to any of our decisions? What does dupe1 do? It's a good question. So you have a stack, right? And you can address that stack. So essentially, you have values on the stack, 1, 2, 3, 4, 5, 6, and 1 at the top of the stack. When you do something like dupe0, what it does, it just duplicates the element on the top. When you try to do something like dupe1, it duplicates the element below the top one, like this. So essentially, dupe allows you to pick an element out of the stack and copy it on top. So that's what it does. And the elements are addressed starting from the top of the stack. Make sense? So we can use it for some other operations, exactly. So this is how we calculate the Fibonacci sequence, by the way. So as you can see, here is the Fibonacci sequence. The stack in this particular case grows down, so this is the top of the stack. So essentially, yeah. So what we do here, we push first 2 Fibonacci numbers, then we duplicate these 2 numbers, and then we sum them up, and then we repeat the process. You see? And this is how we fill up the stack with Fibonacci numbers. Make sense? I just thought about a pretty interesting instruction. That checks whether the stack is empty or not. So essentially, if you let's call it empty, right? What it does, if the stack is empty, it will push 1 on the stack, so then later you can jump if that value and jump somewhere else, and if it's not empty, it will return 0 to you. So yeah, I think we'll definitely need this kind of instruction, because if at some point after calculating Fibonacci numbers I will need to you know, print the whole stack, I want to implement another loop that basically pops element out of the stack until it becomes empty, and we need a way to check if the stack is empty. My notion of the stack is that all the stack frames are closed boxes except for the items on the top. Well, cool. I'm really glad that you shared your notion of the stack. Thank you so much. All right, so let's continue. So we also need to change the names here. So I need to find all of the places where I do something like plus. And well, it's actually pretty straightforward. There's only 2 places where we do all of that. And you know what? Hello, be careful with the null pointer exceptions. Don't worry about that. C doesn't have any exceptions. So we're never gonna have a null pointer exception. Isn't it funny? Right. I think it's goddamn funny. Yeah, I should be careful in languages like Java, because yeah, it does have exceptions, and null pointer exceptions happen quite often in Java. But in C, you don't have any exceptions. You don't have to worry about that. Come on, seriously. Funny that Java calls it that when it doesn't have pointers. Well, you have to consider the context in which Java was created, right? So Java was created in a very interesting historical context when there was a lot of C++ developers. In 2020, there's not that many C++ developers. But in the time when Java was created, there were. So if you want to create the next popular language, you probably have to use the terminology the majority of the developers is using, right? So that's why they have null and, you know, a lot of C terminology in a language that doesn't even have any of these things, because it's just familiar for the people of the time. Anyway, I'm not sure what I'm talking about, whatever. So what are we doing? I kind of want to centralize the place where we store the names of the instructions, if you know what I mean. So we have the types of the instructions, right? We have the type of the instructions, but I also want to have the names of the... I'm so sorry. My lunch is just trying to escape me. Okay. I'm okay. It's everything's okay. So we need to create an array, right? We need to create an array. He's losing it. Yes, I am losing it. Inst names, right? Inst names. And essentially, for each individual name here, I'm gonna show the textual representation of it, if you know what I mean. Cozy White Bear, what's up? What's up? I think I already said hello to you, but hello anyway. 912. Should we call 9? Yes, it's 912. We don't even have 911 in Russia, so it's actually different. I think in Russia it's 112, if I remember correctly. Yeah, it's 112. All right. Wait, this is not what I wanted. I wanted to find inst name. Yeah, there we go. So basically, I want to centralize the place where we have the names, so it's a little bit easier for us to work. Again, I'm in the middle of a dilemma whether I want to use the GNU extension or C extension that allows me to do shit like this. Right, you know what I mean? Actually, not that, but rather something like this. And then I'll have to be a little bit careful, chat, by doing something like this. Query replace that, that, and that. And then have something like, no. By the way, is that a GNU extension? Is it really a GNU extension? Does anyone else support that? I think we discussed that at some point. I think we discussed that, but I don't quite remember. So then we have plus I. Isn't that designed designated initializers? I don't know. It's equals. Okay, so the specific syntax doesn't really matter because it's super easy to change it afterwards. What's important is that I need to type out all these names. So GMP, then GMP if, then equals, then halt, and print debug. There we go. So I suppose people say that you have to use something like this, right? Instead, there we go. That's how easy it is to change. Due to lots of argument, both should work. Oh, okay. So yeah, essentially that enables me with changing the order of these instructions without requiring changing the order of these things. So it's quite important. It works in Russia. Oh, you're talking about the number. For some reason I thought like that Cozy White Bear is from Russia, but apparently you're not from Russia. I mean, it's none of my business anyway, so just a little bit curious. I don't know. You sound like you're from Russia for some reason. Okay, everything seems to be compiling, by the way. Everything seems to be compiling. And yeah, that's pretty cool. That's pretty cool. We definitely need a fancy white bear for a full collection of bears. So you collect data, but no, I don't collect any data. Okay, so I don't collect any data. By the way, here's the interesting thing. Don't I have pedantic here? Don't I have pedantic here? Did that extension become from Poland, but I have family and grandmas in Russia? Oh, okay. Means, yeah. Still the comrade. Still the comrade. All right. Jane Dobry. I'm not even sure if that's how we pronounce it, but yeah. If you change the meta sequence, you break backward compatibility. Probably. That's actually a good point. But right now we don't really care about backward compatibility. Yeah, we're gonna have versions of the API, that's for sure. But again, nothing is stabilized yet, so we're constantly changing everything. So, like, why does it complain about pedantic? I'm so actually worried. So is it? Declaration is specified before size of. Okay. So, what is another standard of C? 89, I think. What was another one? Comma at the end. And what is the for loop? The initial declaration. Yeah, that's really interesting. C11 with pedantic, and it allows this extension. I'm actually very confused. Okay, so what about Clang? CC Clang. All right, so yeah, it's a classical Clang. Complains about something like that doesn't exist. I think it's definitely like a Clang thingy, but yeah. So is it really an extension? Is it really an extension? How is it called, by the way? It is not an extension. Wait a second. C, it isn't an extension. C array. How is it called? How is that feature called? How is that feature called? I want to read more about it. I don't know why, but for some reason in my brain it's just like drilled that this is an extension. Okay, it's a part of C11. Okay, that's actually sounds good. Okay, so how is it called though? Designated code. Okay, designated. All right. Cool. Thank you. That's actually super cool. So I'm super happy that it works now. Yeah. It's perfect. It's fucking perfect. So that's what we're gonna do from now on. Okay. So that means in the assembly, speaking of, I don't have to do any of this shit. Look at that. I don't have to do any of this shit. Except sometimes we don't know if the instruction accepts the operand or not. Oh, we have a raid from Donho. What's up, raiders? How's it going? Welcome to our epic virtual machine club. How about that? Cheers. Oh, finally, Christmas mug is Yeah, on topic. Yeah, I've been using this mug like for since the summer. Yeah, because that's like I have two mugs, and both of the mugs are like Christmas themed. So yeah, finally. Already over by the way. Ah, okay. Very well then. Missed it. All right. So essentially, I need an array that also holds an information whether the instruction accepts an operand or not. So how are we going to call such array? Does anyone have any idea how to call such array? Inst has operand. So, and yeah, it's gonna be just something like this, I suppose. Has operand. Hey, yeah, that's a cool idea. Thank you so much. Yep. I think this is how we're gonna call it. So, nope, doesn't require any operand. Push does require operand. Dupe does require. Plus doesn't. Minus doesn't, because again, plus and minus, they take their operands from the stack. And the same with multiplication and division, but the jump does require an operand because it requires an address, right? It requires an address. To be fair, even for jump, we could have actually get rid of the operand because you could put the address on the stack through push. To be fair, push could be like an only thing that requires an operand. If you think about that. Oh shit, that's actually very interesting. Yeah, you can make push the only instruction that accepts an operand. That's a very interesting. Oh shit, this is so interesting. Can you cut down on the size of the instruction by like exploiting that somehow? If address is relative, operand will confuse because its operand is located on the stack. Maybe, but I'm not gonna do that right now, though. I'm not gonna do it right now. So I'm just thinking, like theorizing. But yeah, that's really interesting. Huh. So again, it's all just experimentation, but it's a good point. Thank you. All right. So I want to do align. Yeah, there we go. So we're gonna align this entire stuff, and another thing I'm gonna query replace align that. Align. Can your Vim do that? Can your Vim do that? I don't think so. No, I don't think so. Anyway, so we have these tables. And now to implement the assembly, we don't even need this dumb switch case. The only thing we need to do here is essentially printf the instruction name, inst name, inst names, and the instruction itself actually, I think, is located here. So you use the type of the instruction as like for that. And then you need to check another very important thing. Does the instruction inst has an operand? Does it have an operand? And if it does have an operand, we may as well print that operand right now. Printf ld. We're not going to even put new line here because we can put a new line afterwards. So here it is, and then we can get rid of the whole switch case here. Look at that. Look at that. And then later, if we're going to change the name of any of the instructions, we don't even need to change this assembly. Forgot the space. Where did I forget the space? The compiler will tell me. Oh, you mean? Oh, yeah, I see. So yeah, the compiler won't tell me. Thank you so much. Thank you. All right. That's cool. And it compiles. So, and it's quite important to actually centralize the name of the instructions because then I don't have to worry about synchronizing assembly and disassembly. Right? They use the same like table of instructions, and it's actually kind of cool, I think. So, what's going to be the next step? I want to double check that the bosom still works. Examples BM. It does work. It does work, and it even supports +i. Nice, 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 nice. It does support +i. So the next thing, we need to find where we use push and stuff like that. Yeah. I guess what I have to do now is inst name. Wait a second, can I use a little bit of Emacs magic to achieve that? I think I can. Look, so we have plus, it's gonna be +i, and the only thing I need to do is use multiple cursors like this. Yeah, now look. So here's the instruction type. Yep. God damn it. Inst, like this. Inst names. Right? Boom, boom. Can your Vim... Well, Vim can do that actually, so I don't know why I'm saying that. Maybe we can even simplify that even further, because the only differences here is that, well, we still need like a special treatment for the jumps and stuff like that. We still need to do like a special treatment. So I'm not going to do that right now, but so far it does in fact compile. So far it doesn't in fact compile. That's actually super cool. So another thing I want to do is build the examples and see how they will fail. There we go. Oh, no. Yeah. So unknown instruction plus. Unknown instruction plus. So this is exactly what I'm looking for. But again, we have a very crappy error messages, which don't tell us anything, like where exactly the thing has happened, so we have to guess it, but we have an issue to fix that. So this is, it has to be +i. There we go. And also we need to fix another example, which is 1 to 3. So essentially we have to do +i here. Examples fails successfully. Yes, exactly. Cool. So, and the next thing I want to do, BME, examples, fibs bosom, it's an input, and the limit is going to be 69, and oh yeah, I should actually, yeah, I'm trying to execute assembly file instead of bytecode file. And it's actually pretty cool that assertion worked, so it didn't try to do any harm. There we go, it still works. It still works. We have special checks in place, so it's absolutely safe. You see, you don't need to have a Rust to write like safe virtual machines and stuff like that. It's pretty cool. And also we have this thing that sums up 1 to 3, and the result of 1 to 3 is 6, as you can see. It's pretty cool. It's pretty cool. Hello, potato passing by. Welcome to the stream. How are you doing? Do I still have tea? Yeah, I do still have tea. Cheers. Okay, so we successfully renamed shit. How about that? And we even refactored some stuff. We managed to get rid of this huge switch case. Isn't that amazing? We just compressed it down to this thing. But I never checked disassembly. Let me double check disassembly. So fibs BM. Disassembly works. Okay, disassembly seems to be working, and yeah, it's actually kind of cool that the instructions now are centralized, the names of the instructions. So it's going to be very convenient in the future. Okay, so let's commit everything here. Rename, excuse me, integer arithmetic instructions. There we go. I'm gonna push that right into the repo. You can find the source code of the thing we're developing here. And finally, we are ready to introduce floating point instructions. Yes. So we only had integer instructions, but now we have a space for floating point ones. How are we gonna approach all of that? Right. So it's gonna be something like this. I'm gonna select everything, query replace this with this, boom, there we go. So now, if I try to compile this code, hopefully it will fail, telling me that I don't have like a full implementation like like full cases here and full cases here and some switch cases and stuff like that. Yeah, we're gonna have plus. We're definitely gonna have plus. There we go. Oh, this is very interesting. Type. Oh, it's instruction type as sister. To be fair, should have actually made it a function as this one. But I mean, it's okay, I think. I don't know. It could be yet another like bike shading of, you know, switch case function versus array. But array could be faster, maybe? I don't know. Boom. You can replace it with macro, probably. Okay. Here's another one. So when, okay, so this is actually very important now when we are executing instructions. So this is instruction execution. Instruction execution. And on top of that, we also need to come up with the name for these things, right? So here is the name. Let's query replace I with F. Boom. And another one, I'm gonna query replace I. No, this is not what I wanted to query replace. I wanted to query replace I with F. Boom. There we go. Similarly, we need to add this information here, but maybe not. Look, the cases that are not presented here, right? If I have some missing cases, does that mean that they're going to be automatically initialized with 0? Does anyone know? Is there a technique to stringize tokens in C with macros? Yes, there is. You can literally Google it up. C macro stringify token. C macro stringify. Stringification. So yeah, and it shows you like example on how to do that. Just Google it up like that. All right, that's cool. That's actually pretty convenient. So it's automatically 0. You don't have to worry about it. Oh, it wasn't a question. I'm sorry. I see. Oh, I see what you mean. Yeah, I could have just used that instead. Okay. But I already moved on to the next thing. So yeah. Okay. So now we need to implement a logic for our floating point instructions. That's what we need to do, boys and girls. That's what we need to do. Is there any easy method of calculating pi? Does anyone know any simple and easy way to calculate a pi, which I can quickly code in for a virtual machine? Won't that point to wrong memory? I'm not sure what you mean. Writing Vim in C, nice. Yes. Could be pasted from Google, but I need the name. All right. So let's implement the floating point instructions. So this is going to be that. Case inst plus F. So we're implementing plus F. So plus F requires. Oh, that's actually very interesting. You can, since we know, we can also store an information about each individual instruction, how many elements on the stack it requires, right? And generalize these arrow checks and stuff like that. I think that's interesting. Because the arrow need for arrays will only work if you specify the array length, right? Yeah, probably. Goddamn. All right, we can probably test it out, but I mean, it doesn't guarantee, right? It doesn't guarantee. Okay, so, but the problem is that I don't know the size of this enumeration, and I really hate this pattern. I really hate it, because it kind of screws up everything. It kind of does. And it also looks like one of the instructions. number of insts. We can put it like that. Maybe amount of insts. And we can put it like that, and we can put it like that. Number of insts. And that means it will fuck up some of the places, like for example here, but we can do the following thing where I can do like case inst amount of insts, and we're gonna like fall through here. We're gonna literally fall through here. MM2PL, welcome to the stream. How are you? I always do count. Well, yeah, me too, but it just like it feels like it's one of the instructions. And to be fair, count sounds like yet another instruction, but it's not an instruction. It's just a hack to get the amount of enumeration. So that's why I want to kind of call it differently. Size, well, yeah, but I already explained my reasoning why I don't want to do that. Okay, so here is another thing. So this one is an illegal instruction, and we can also amount of insts. We can also redirect it here, right? All right. Cool. So where is the plus? Plus. So we need to implement plus number of. Okay, I like number of a little bit better. So this is a last bit of bike shedding, okay? This is last bit. Number of inst. Cool. Bike shading is hitting so hard. Holy shit. Okay. So if bm stack size, we need to implement the plus f instruction. Will C give you a warning on a fall through? I think in some particular situations it will, but I don't remember. Wanders in and waves to what's hello, welcome. Hello. So GCC fall through warning. Implicit fall through in GCC 7. So there is warnings, but I don't think it's enabled in W all and W extra. So let's actually try to, for fuck's sake, Americans, it's not that hard to just not send me extra cookies. Like GitHub actually showed everyone that it's not that hard to get rid of this thing according to GDPR. Americans, what's wrong with you? Holy shit. Okay, so W implicit fall through. Implicit fall through. Okay, I'm not gonna even agree with or anything. Okay, so does it complain about anything about fall through now? It doesn't complain. I wonder why. Okay. GCC fall through warning. Has a cookie allergy, yes. Alright, whatever. Doesn't really matter. Doesn't really matter. Yeah, by the way, like, do you guys remember this article by GitHub? Like, because I don't know much about GDPR because I never had to deal anything. I never have to deal with it because I never developed a website that requires cookie, and I didn't know that you don't have to put this the pop-up bullshit if you just don't use any Google Analytics or anything like that, or if you just use like essential cookies for authentication. I thought if you use any cookies, you're obligated to constantly like to take the consent of the user. I didn't know that, so it actually makes it super easy. Like, why no one is doing that? Like, what's wrong? It's just super easy. Just don't do that. I have to use 99 at work. I don't know. I never I'm not familiar with GDPR. Of course, the GDPR is not made to annoy people. That's actually pretty nice. It's actually pretty nice that they consider these kind of cases. Like, and okay, you can argue that you need analytics for, you know, for your business cases and stuff like that, but you can derive so much information just from the logs of the server. Like you could just look at the log of the service, like write some scripts that parse them and present you reports and shit like that. Like you can do a lot of shit with just that. It's just really strange to me. Like I don't understand that. But again, I'm not really developing any website that requires all of that. I'm just like speaking from a perspective of a non-web developer. So maybe, obviously, I don't understand something. I don't understand like specifics of all of that. But it just sounds weird to me. Advertising, yeah, I suppose people just get too dependent on things like Google Analytics and like maybe Facebook Analytics or something like that. They just get like they cannot get rid of them, and that's why they keep showing you these pop-ups. And maybe replacing them takes very expensive developers that the companies cannot afford or something. People already made analytics that scrape the server log. Nice, because it's a better way. And what's funny is that, as Provat said, I remember Provat said that you cannot even ad block this kind of analytics, right? You cannot ad block the server logs. So it's even better because you can like derive information that is impossible to block. So, I don't know. What the hell servers doesn't even mean? It doesn't mean anything. It's just it's a marketing word for the managers. So essentially, if I understand correctly, this is a buzzword designed for the managers specifically, not the programmers. It's not for programmers, because if you say if you try to sell this technology to a programmer will instantly call a bullshit on that, right? Because programmers do understand what they're talking about, usually majority of them. So how does it look from the manager perspective? How does it look from a manager perspective? Right, managers go to the programmers and say when the feature is going to be done. Oh, we need to configure the server. Oh, our server is down. Or our server that. Oh, our server that. This. Our server that and that and that. They keep saying there's something wrong with the server. And then a company like Amazon comes in and says serverless. And managers like, holy shit. My programmers are constantly complaining about this thing called server. And you suggesting to get rid of server. Holy fucking shit, yes, more of that. So this is how it works. So it's a marketing word designed not for the programmer, and this is exactly why you cannot understand it. So, records and plots, you don't understand this word, and that is not a bug. That is not a bug, it's a feature. You're not supposed to understand the meanings of that word because this word was not made for you, it was made for the managers who don't know what is a server. So that's how it works. I'm not even fucking joking, seriously, that's how it works. And this is fucking disgusting, and this is why I'm unemployed. I'm not joking, this is exactly why I'm unemployed, because I've been through this shit so many times, I understand how their brain works, it's fucking disgusting. Anyways, let's continue. This is why I don't go into CS. Well, it's actually not false. I could be a good manager. I wouldn't say I would be a great manager, but I think I could be a good manager because I kind of understand how this entire like politics works. But at the same time, I don't like it. I don't like to like be part of this process. It's just kind of disgusting to me. Hello, Freefu, welcome to the stream. Okay, good. Let's continue. So stack size. Okay, we have some shit on the stack. We have some shit on the stack. It's like shit on the stick, but shit on the stack. All right. God damn it! I'm sorry. I'm sorry, Nico. I'm sorry. I'm sorry. I forgot to fix the boat. I'm so bad. I have so many things to do. I keep forgetting them. And that's why I'm unemployed. Anyway. Does work in web dev, IT security, hardware, near stuff pays better anyway. I was actually considering to getting into IT security, to be fair. But I wasn't sure. Because I think I have enough skills that would allow me to be good at IT security, but I don't know. Okay, so for the plus, we only need 2 elements on this stack. So we don't really need to check anything else. So I'm gonna do it like that. There we go. So it's kind of the same as plus I, but except interpreting the words as U64, we have to interpret them as F64. There we go. Then we consume the stack and increment the IP. There we go. So we implemented the plus F. To be fair. Oh, hello, Panapudi. Welcome. Welcome to the stream. How are you doing? Sorry. Bold Bancraft Birchfield machine. Oh shit, I should have called it Bold Machine. I think we already discussed that. Yeah, should have called it Bold Machine. Alright. Let's try to compile this thing and see if it's gonna work. Okay, so plus F instruction compiles, and I'm super happy about that. Let's maybe test it. So we have 1 to 3 integer, right? So how about we make a version which is floating, right? If you know what I mean. So here's the, oh, this one is not gonna work, by the way, because in assembly we'll need a support for floating points. That is very interesting. We need a support for floating points. Okay. We can try to though. So essentially I'm gonna do 1 to 3 F bosom, and what I expect here is push 1, 2, 3, and then plus and hold. There we go. So this is gonna be our simple program that does all of that. And we'll see if it's gonna work or not. But we need to add that to the build process. Okay, I'm gonna query replace 1 to 3 with 1 to 3 with 1 to 3 I, right? And this one is also a 1 to 3 I. I need to copy paste that stuff and query replace 1 to 3 I with 1 to 3 F. There we go. And now I'm gonna add this thing to the dependencies, right? Like this. Unknown instruction plus F. There we go. So we're already starting to have errors. Yeah. Holy shit. Thank you. Thank you so much for 10 months of tier 1 subscription. Thank you, and welcome to our epic Bold Club. Thank you so much. I was customizing my Razer Huntsman Elite by adding some new keys and loops. Now they look more like Ducky 1.2 mini but longer version. Are you a bot with Markov chains? That's a pretty good Markov chain. Thank you so much. All right, so yeah, but it's too obvious. I think it's so obvious. All right, so we have to wait for the next message of that bot, and if the next message is going to be as scuffed as this one, we can confirm that it's a bot and we're going to insta-ban him. So yeah, so as I already said, we don't have a plus F instruction, so let's quickly implement it. Unknown instruction, so we need to do plus F. All right. Else if. All right. So here we have instruction name. Oh, it's getting cold, by the way. Oh shit, it's getting cold. So I will have to change my clothing yet again. Oh shit. SV equal. I mean, more content for me. What can I say? So what I'm trying to do here is the instruction plus, right? So we're trying to do instruction plus. And in case of instruction plus, oh, this one is actually pretty straightforward. So the only thing you have to do here The only thing we have to do here is plus F, right? Plus F. So that should be pretty straightforward. Hit yourself by compiling boost. That's a cool idea, I think. So value is neither. Oh, okay, it's actually has to be names. There we go. Cool. We managed to compile this entire thing. Okay, and I'm gonna show you something scuffed. Chat. Look. So here's the bosom of the original program that we wrote. If I try to now disassembly the bosom, the compiled binary, it doesn't exist even. Oh, because yeah, look at that. What it's doing. Oh, segmentation fault. Holy shit. That's really nice. So we have a segmentation fault. So it doesn't even work properly. Nice. And the original one, as already showed, is actually plus. So it interpreted plus as a jump 0. That's very interesting. It's a virtual segmentation fault. Yeah, sure. So yeah, that's pretty cool. Push hype. No, we're not gonna have push because push you only need one push operation. You don't need like several for different types. I think it's kind of like redundant. So okay, I'm gonna make a cup of tea. Does anyone have any questions while I'm making a cup of tea? You have wrong variable name, you get plus for name. Yeah, I guess. Thank you, Kramer42, for telling me that. Really appreciate it. Does anyone have any other questions, maybe? Will the decompiled ASM compile? According to the design, yes. So if the decompiled ASM doesn't compile, it's a bug and it has to be fixed. So the expectations are, so bosom and debosom are idempotent. I forgot how to pronounce that word. Idempotent. So yeah, so basically you can just compile, then decompile, then compile again, decompile, and it's gonna work. If it doesn't, it's a bug. Idempotent, I think. Thank you for wishing me a nice stream, Of course, 94. Bye bye. See you around. Do you work off a design sketch or just type straight from your head? I'm typing straight from my head and see what works, and then change if something doesn't work. In future, it might be JITted. Will you use something like libgcc JIT? No, we're gonna do it ourselves. We don't have any third-party dependencies, and I don't see any reason to add any third-party dependencies. Yeah, so why would I do that? It's kind of strange. Does anyone have any other questions? Let's actually progress. Yeah, I think it would be interesting because I'm also doing this project for educational purposes, not only recreational ones. Have you ever did design first before implementation? Probably. I don't remember. I just don't want to do it in this specific case. I don't feel like doing design in this specific case. Thoughts on Ruby 3? I don't program in Ruby. Sorry. I know nothing about Ruby. Alright. So, I think we need to make a small break. Because I also need to pee. Right, because I haven't peed for quite some time. For 2.5 hours I have not peed. And it's kind of difficult. So, and I think we're gonna do now, boys and girls, we're gonna make a small break for, let's say, maybe 2 minutes. Yeah, I think 2 minutes should be okay. And then we're gonna continue. Why do you use a terminal instead of IDE of text editor? Why not? All right, let's make a small break and you guys have fun. Yo, what's up, epic gamers? I was just on time, okay? I was just on time. Don't tell me anything otherwise. All right. Bosom, we need to figure out what the fuck is going on with the debosom. Why debosom is so scuffed. Maybe if I go to completely rebuild everything, that could be the thing. And if I run it one more time, there we go. So the problem was I forgot to rebuild debosom. Yeah, speaking of backward compatibility, right? Speaking of backward compatibility, yeah, we don't have it. That's why you can have these kind of situations here. But to be fair, why did we even hit this situation? And I know why, because we use these arrays, right? And if you go outside of that array, you're gonna have a bad time. Alternatively, we could have a function with switch case like this, where out of the range would be instantly assertion. Right, would be instantly assertion. We actually figured out that this is not a GNU extension, apparently. Apparently it's a part of the standard now, but I'm not 100% sure. Yeah, I kind of want to turn all of these arrays, at least the name array, into the function with switch case, because I think it's kind of like more type safe. Anna both. What's up? What's up? Welcome. How are you doing? Really, let's see. What do you guys think? I think it's gonna be cool. Really? Which standard? Maybe C++. I think we saw that in C++. CPP. What extension? Designated arrays. Array initialization. Array initialization. Wait. We had the thing with the array initializer. CPP reference array initial C. Okay, so first we're looking at C array initialization. Cool. And there we go. We have this thing. So designators, different designators. So I would assume that CPP reference is talking about the standard. But since when it was introduced? I'm not sure. Maybe C11. So this is what... Yeah, well, Aguduk already provided the link. Alrighty. So, what I want to do, I want to change these arrays. Change these arrays to that. Yeah, let's quickly do that. Static, does it have to be static? No, it's going to be const char inst name, and we're going to accept instruction type, right? Instruction type, and we're going to simply just do it like that. Maybe it's going to be switch. Bye bye, rook IVRM. Well, see you around. The other day I was writing something like that as well, I remember, with strict C99, so I guess it is okay. Yeah, I'm actually also surprised, it's kind of strange, but okay. Alright, let's do the following thing. I'm gonna use multiple cursors to do a little bit of Emacs magic. So it's gonna be like this, case. Okay, this is not really convenient because print debug ruins everything. So I cannot just jump twice here because, as you can see, print debug has three tokens instead of two. So I cannot reach this square bracket. So what I'll have to do instead, I'll have to do something like this instead, I suppose. And I already fucked up because I overshoot one more time, and a boom, 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 and then we can simply return this entire stuff. Boom. How about that? How about that? So, and then after that, we can do something like case default, and this is where we can assert, saying something like inst name. I said inst name unreachable. There we go. Inst name unreachable. So, and we're gonna get rid of this array because it's not really safe in my opinion. I don't think it's particularly safe. But why not check if the range between, because I can forget to do that. Does it make sense? Does it make sense? I think my water is ready. I think my water is ready, and I'm gonna quickly brew up some tea. Don't go anywhere, or as usual, you're gonna get banned. I'm sorry, but yeah, don't go anywhere. Welcome back. Which transfers are that? Audio Technica something 5069 420, I don't remember. Okay, so we need a similar thing. Inst has operand, alright. Bye bye, Annabeth, bye bye. Someone registered PP reference. That's a good one. Instruction has operand. Instruction has operand. Inst type. Type and this one is kind of, yeah, I'll have to do like a similar thing, but I'll have to return it one more time. One more time. Yep. And I think I already did a strange fucky wacky thing, but anyway. Alright, so does anyone have any questions maybe? Does anyone have any questions while I'm doing this thing? It's gonna be 0, 0, 0, 0, 0, 0, 0. It's not used, such a wasted potential. Yeah, it's kind of sad, but it's a, yeah, it's a pretty good PP reference. 5+ hour streams again. I don't know. We'll see if I don't get tired. Maybe. Who knows? Who knows? Maybe. So okay, push and dupe accept this thing accept this thing. Okay, cool. Inst name unreachable. So that's basically checks for all of that. Okay, so now we have this situation, inst name, and this is how we can, oh shit, okay. So the time has come to craft a perfect regular expression. I'm gonna show you how we're gonna do that. Look, look, look. So query replaced by a regular expression. So we need to capture everything inside of here, right, like this. And we need to replace that with inst name 1. And it didn't fucking work because we probably have to escape this thing as well. The brackets. The brackets needs to be, yeah, there we go. Look. Can your Vim do that? Can your Vim do that? I didn't think so. No. Fuck, it actually broke more shit. Inst name is not a function. Okay. So why is it not a function? It is a function. What the fuck are you talking about? Called object inst name, which is not a function. But it's a function? What are you talking about? I just look at the standard, it is a valid C99. Yeah, it's actually cool. I didn't realize that. We watched a video where it was not. Ah, it's probably not in C++, but it's yet another case of C++ being PP, guys, I think. I guess that's what happened. I guess that's what happened. So essentially we have a local variable, inst name. Yikes. Yikes, 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 yikes. I need to come up with a different name now. Chat, it's painful. Like, I ran out of names. How do I call this thing then? How do I call this thing? I could call it a token. Yeah, we can call it a token, I suppose. Yeah, token. Let's call it a token. Why not? C plus Pepega. I guess. So let's query replace inst name token. So this is gonna be a token. And then in here, this entire thing, right, is gonna be query replaced with token. This is not what I wanted. Query replace. One more time. One more time. Query replace that with token. Boom. Can you redo that? Is it gonna compile? Okay, it's almost compiled, except for this case where I can just say token, token, unknown instruction, token, token. Okay, so now it primarily compiles, except here. So, oh yeah, there we go. So where is my other thing? Yeah, this one. And another situation here as well. Has operand, inst has operand. There we go. Are we ready? Finally, everything compiles. Cool. So we got rid of these arrays. Now we have functions that are a little bit more safe and they check and stuff like that. So that's pretty cool. Let's make a cup of tea. It's gonna be an actual VM like with an operating system like VMware and VirtualBox? No. It's gonna be VM in a sense of like JVM. Have you heard about JVM? Alright. Why not functions that checks array boundaries? Because you already have a function. If you already have a function, you could at least... Look. You're suggesting to have array and function. I'm suggesting to have just a function. Less complexity. So you're suggesting to add two things. I'm suggesting to add one thing. Which is better? The one with less complexity. One function is less complexity than function plus an array. Okay, so let's continue. Again, we have this situation, and this is not gonna work. This is not gonna work, by the way, because if I try to execute BME, right, and yeah, it has to be an input, we got a result 2. Actually, we got result this. We got result this. So the result turned out to be 0, but we were summing up 1 to 3. We were summing up 1 to 3. And you know why? Why the result is not 6, but actually 0? This is because we interpret 1 to 3 as integers at translation time. So essentially our assembly doesn't support floating points. That's the problem. It just doesn't support floating points. So the thing we need to do, we need to now modify assembly that will support floating point literals. So the question is how we're going to even do that. So we can probably use one of these functions like str2d, there we go, which can, you know, parse that shit. Convert ASCII string to floating point, but I really don't like them because they expect null terminated strings, which make it difficult to work with and stuff like that. And we're actually parsing not null terminated strings, but we don't really have that much choice anyway. So we'll have to do that. Okay, let me see what we can have. Before I go into that, I want to commit whatever we have already, chat. And what do we even have? Null terminated string should be default. I mean, sure. Okay. So what we're gonna say here? Add stub floating point instructions, arithmetic instructions, and I'm gonna push that right into the repo. BM translate source. In the BM translate source, what are we doing? Where is the push? Okay, here's the push. And in the push, we're just taking the string representation, string view representation, and we're trying to convert it to integer. But is it really an integer? Right, we need to distinguish the integer literal and the floating point literal. I have an idea that maybe we can end the floating point literal with f or something like that to indicate that it's that. Or maybe we can have like some sort of like heuristic that checks whether it's a floating point or not. In any case, we need some special function. Some special function to handle all of that. That function, in my opinion, should accept the string view and return you a word, right? Parse literal number literal as word. So that's what I'm trying to do here. Number literal as word. So here essentially you have some sort of a literal and you get a word out of that, and this is where we're gonna have all of our decisions made. So as I'm gonna put 0 here, right? So where is the instruction push? And instead of sv to integer, it's gonna be number literal as word. And by the way, we don't really have to wrap anything here because depending on the literal, it's gonna be we're gonna use as use64 or as int64 and so on and so forth, right? Depending on all of these things. And this is where we have to start like making all of these decisions. And again, we need null terminated string. We need null terminated strings where we can dump this entire thing, and just work with it. So I would like to allocate that on the stack, and this is one of the things we can do, by the way. We can create sister sv count +1. You see what I'm doing here? And this is, as far as I know, allowed in C, in the latest C. I forgot how it's called. They have like a fancy name for this kind of technique so they can look smart in front of the plebs, but unfortunately I don't remember that names. Can anyone tell me that like a fancy name that everyone just uses to show off in front of their friends? How is that called? Because I can never remember. I just never remember names of the features. I just use features. VLA, thank you so much. VLA, yes, that's the fancy name that everyone used to show off. Okay, whatever. And I think we also need to do assert, because I don't want this string to be too long. We can do something like count is less than 124. I think if you have like a string greater than 124, there's something wrong and you shouldn't be doing that, right? Anyway, so we might as well actually like assert that here. And then we can mem copy this entire thing, right? We can mem copy this entire thing. It's going to be str. But by the way, before we're going to try to mem copy anything, let's try to compile this thing and see if it compiles. It doesn't compile even. Oh, it may not be initialized. Would you look at that? You cannot initialize it. Okay. All right. So what's the another error that we have here? Expected something something. Expected word out of that, and there we go. It does compile. Look, yes, it does compile. So basically it will just allocate this thing on the stack for you. And another thing is, like it's similar to alloca as far as I know, right? So it basically allocates the memory on the stack, which will be deallocated automatically. But now you have this as a part of the language, which is quite convenient, not gonna lie, quite convenient. Anyways, so memcopy. So the destination is going to be src, the source is going to be this, and the amount of bytes we're going to copy is count. And after that, we can do sister svcount equal 0, and there we go. We have a sister representation of this string view that is going to be automatically deallocated. We don't use any malloc or anything like that. It's actually super fast and it's pretty cool. Is the push is 1 and the push 1 literal or index? It's literal. All right. What kind of heuristics we're gonna use here? So for example, if it is if it contains dot, right? If it contains dot, we can try to interpret it as double, right? So this is one of the things we can do. And if it doesn't contain dot, we can try to interpret it as integer. Okay, so can we use something like strchr to find this thing? I think we can. So if strchr sister, and we're trying to find dot, if it's not equal to null, what we have to do is str to d, right? Str to d. And this is how we're gonna approach all of that. So it's gonna be str to d. This is the sister, and we also need end pointer as an indication that we even managed to parse anything. Yeah, push uses literals. Yes, it uses literals. We don't. Maybe I'm gonna have labels at some point, but we don't have support for labels yet. We'll see how it goes in the future. And pointer is gonna be null. So yeah, we're gonna keep it here. So for those who doesn't know how str2d works, essentially you provide the C string, multi-terminated strings, and you also provide a pointer to a variable that will be assigned to the end where the parsing ended, right? And if parsing was not successful, the end pointer is going to be equal to the beginning of the string, indicating that nothing was parsed, and this is the error that we're looking for. As a matter of fact, for now we don't really care about error messages that much, so we can put something like this here, right? And the result here is going to be something like this. The result is going to be something like this. So it's going to be x, then we check that we managed to parse something, and then we can safely return word as f64x There we go. So, if we have a dot here, we try to interpret it as a floating point, which may not be enough because you may have like this like notation. I forgot how to do that. Yeah, this kind of notation. But yeah, the assert should be not equal. Yeah. Thank you so much. All right. So next one, A to L, str to LL. I think that's what we need here. Str to LL. Yeah. So what str to LL returns in case of the... Oh, it's the same situation. Cool. Huh. What I'm thinking is, what if we try to first parse it as floating and then as an integer? It's kind of... we're kind of losing like control over all of that if we're trying to do that. Okay, so let's try to do it like this. I need end pointer yet again, so I'm thinking I'm gonna put it outside here. So it's a long int, but do we have like a long u as well? str to ul to ull. Yeah, this one is getting complicated because you have to be super careful. Okay, long int, it's just gonna be that. So this is a sister, this is gonna be pointer to end pointer, and the base is gonna be 10. And again, we want to double check that everything went okay, and in that case we can return as u, it's actually not u, 64x. Yeah, something like this. But that is not enough even. That is not enough. Okay, so here's the problem. If you have something like this, I want to implement it as the following. We can try to parse it as double. If it doesn't work, we try to parse it as signed integers. Then if it doesn't work, we can try to parse it as unsigned integer. Every int in BM is 64. Yeah, it's a 64-bit machine. It's kind of intentional, but maybe in the future we can try to do something about that. I'm not sure. Do you check the value type when doing int float arithmetics, or do you just assume the stack values are of the desired type? I assume them to be of the desired type, and I have two sets of instructions. I have plus I minus I multiply I, and plus f minus f, and so on and so forth. So essentially you just put some bit string onto the stack, and you have to know what you put there, and then you use a corresponding instruction. And depending on the instruction, it will interpret it differently. Does it make sense? So, but on top of that, we also have assembly. And what I'm working on right now, I'm working on assembly language for that virtual machine. On the level of assembly language, on the syntactically, I need to have different string literals. So that's the problem here, right? Base 10 only right now, yes, because the code is not finished. Yes, the code is not finished, yes, base 10 only. All right, so let's continue. Number as something number literal as word. There we go. So how are we gonna approach all of this? I'm gonna try to parse it as... What's gonna happen if you have a negative number and you try to use str to ull? You know what I mean? I have a bad idea using a regex to recognize. Okay, thank you so much for the idea. All right, so let's see. That's a cool idea. I really appreciate it. lib int, and I think we need strings as well. So const char sister, right? And let's put something like -69, right? And then I'm gonna use a special function str to ull. There we go. So this function. Technically, this function shouldn't be able to parse this stuff. I just want to see what's gonna happen. We provide the sister, so this one is gonna be like x. Then we need to provide the end char end pointer. Because I've been kind of following along in Rust, and I made stack values be in num variants, int float currently, and I was wondering if the type checks would have a significant impact on performance. I have no idea, but we're definitely not going to have any type checks at runtime in the virtual machine. So, yeah. At least for now, I don't know. I haven't decided on a lot of things yet, so I'm not sure. I'm not sure about a lot of things here. Okay, so I want to print f is going to be LLU. So this is the value that we managed to parse. And on top of that, I want to see how many of the values we actually managed to parse. So do we have to use z for that? I'm not sure. So end ptr minus sister, and it should give me how many of these things we managed to parse. Okay, so if I try to compile this entire thing, what's going to happen? It does in fact compile. And if I try to... Okay, that's really interesting. Let's put it LD here. There we go. So this is what we got. It parsed it successfully. This is really strange. So it parsed it as negative number, and then it interpreted it as unsigned one. I was hoping that it will fail, right? Because I'm using function for parsing unsigned values to parse a negative one. So I would expect that such function will fail, saying that, well, it's not an unsigned value. But it parsed it as signed one and basically casted it to the unsigned one. This is what this function did. I would never expect such behavior. Would you? This is so strange, because look at that. Like, we're parsing like unsigned one, and it just gave us this thing. And I can try to do something like LLD, and it's 69. There we go. Expect the unexpected. This is such a strange behavior. What the fuck? Is that like a standard behavior? Okay, let's read about it. Converts the initial part of the string to unsigned long value according to the given base, which the string may begin with arbitrary amount of white spaces, followed by a single optional plus minus if base is 0. Okay, these are functions for unsigned parsing, but they parsed signed one. Holy shit! What the fuck, really? This function operates like str2l to interpret the string, but produces the numbers of the signed. Yeah, I already see that. Like, I didn't need to look at the return. They already say that they expect plus or minus, so... Okay, returns either the result of the conversion, or if there was leading minus, the negative. Well, I mean, it's even better for us. So basically, we can always assume the unsigned values. You know why? Because if it's signed, because we're assigning it to word, right? We're assigning it to word in our case, right? So we can just use to LLU and just have unsigned here and just have something like this. Because then later, if you have a signed situation, right, it's going to be interpreted as a signed one. Don't you love tooth complement machine? Yeah, I absolutely love them. So, okay, it actually simplifies the work for us. What's up, old man? Welcome to the streamers. Welcome. How are you doing? So that's actually interesting. Not bad. Not bad at all. So how are we gonna try to interpret all of that? So maybe I have to first try to parse this thing as a float, as an integer. I'm gonna try to parse it as an integer, and if it is not parsable as an integer, I'm gonna parse it as a float. So the problem with parsing this as an integer is very dangerous, right? For example, if I try to do something like that, that will be parsed successfully. Right, as you can see, it parsed successfully. So what we have to do, we have to look at how many of the symbols we parsed, and whether we parsed the whole thing. Right, so we know the size of the string. The size of the string is 5, but we've parsed only 3, so that means we didn't parse it, right? So we try to parse this thing as a float, and if it is not fully parsed, we try to parse it as an integer, and if it's not fully parsed, as a float. Make sense? Makes sense. So that's going to be our heuristics, if I understand, if I pronounce this word correctly. Okay, so that's going to be the plan. Very interesting. Very interesting. Okay. So parsing it as this thing. Cool. No. What? You need to train. Oh, okay. Jesus Christ, gee. Okay. So, literally debated me. Don't worry, it's okay. So, yeah. So we try to parse it as this thing, and if end pointer to minus str is not equal to n, where we know the size of it. Size is already this actually. It's count. If it's not equal to that, then we try to parse it as the floating point. We try to parse it as a floating point. It's going to be like y. So it's going to be str to d, and if end pointer minus str not equal sv count yet again, we'll have to maybe say a couple of bad words. Error s is not a number literal, right? And we're gonna provide it sister. There we go. And then we're gonna exit all of that. All right. Otherwise, so it's gonna be like a tree of decisions. We have to return word as f64y. And here, otherwise, we have to return word as u64, but x. So here's an interesting thing. Maybe I need to introduce something like a result, right? A result, which is going to be just this. And I can just do a result as u64, right? And then here, result as f64, and just remove that, boom. Isn't that cool? So you have the result that you're gonna 100% return. You try to convert it to u64, so no intermediate variables or anything like that. No intermediate variables, right? If we couldn't parse it, we again assign it to that. So a result is basically a variant. You can put anything there, but it's a variant that it doesn't store any type. All right, so if I try to build this entire thing, will it work? It does not work. Let's take a look at the error. So end pointer is not available because I probably nuked it for some reason. Let's do something like this, end pointer 0. Let's see. And we don't have a reference to str2llu. That's very interesting. But I literally have it here. Men str2 to ull. Yeah, it's to ull. To wait. Oh, it's a wrong file. Where is it? To ull. Cool. This compiles. Yezu kawaii dizu. Okay, that's very interesting. So, and in a disassembly, it's gonna look very, very interesting, trust me. Because disassembly knows only how to print integers. It knows how to print integers, so it doesn't really know how to do anything else. So, okay. Again, let's try to build all of the examples in a different folder. And they do build. Okay. Examples 123f bm. And this is not cut. I didn't want to do cut. I wanted to do well, I wanted to do cut, but on boson. There we go. One more time. I want to reset the state of the terminal just in case. There we go. So we have floating points here, and if I try to disassembly whatever we managed to convert here, there we go. This is what I expected. You see what's going on here? You see what's going on? But it's still correct, and I'm pretty sure if you try to compile this thing, you will still get a correct program anyway, because it just doesn't matter. Yeah, I triple E for floats is... Oh, Jiang, thank you. Thank you so much for gifting a tier 1 sub to Ikura Bowl. And Ikura Bowl, welcome to our IEEE 754 club. Yes. Thank you so much. All right, so this is what we have here. That's pretty cool. And let me see. So it's going to be BME. The input is going to be example 123f. And I'm not going to limit any instructions. There we go. Look at that. So this is the only value on the stack. So we have only one value on the stack. According to that value, these are the integer representations, but the floating point representation of this thing is 1.5, which is completely fucking incorrect, and I don't know why. But at least it's floating point shit. Look at that. At least it's floating point. So yeah, that's really interesting. So we're supposed to have 6. We're supposed to have 6, but we don't really have 6. All right, investigation time. Rounding errors. Yeah, probably. No previous prototype. Oh yeah. Okay, so we have a couple of problems here. This thing has to be moved to the implementation section somewhere here. So I have to refactor this thing a little bit. So inst name. Oh, yeah. So it has to be like that. And this one is inst has operand. Right, and this entire thing has to be moved to the implementation section as well. Inst has operand. It's going to be put like that. And there we go. So now it does have prototypes. Okay, so here's another situation. So where is plusf? Do we have plusf anywhere? So here's the plusf. But we interpret all of that as F64, so I'm not sure what the hell is going on here. So it should be all right. Okay, so this is enumeration, no previous prototype for this thing, which is understandable. So let's find this situation. Yeah. No comparison of integer. Okay. So count is size t, long integer, and this is so that means we can turn this thing into size t, hopefully. You have divided. Oh, okay, probably. I just probably copy-pasted one of these. Thank you for finding that for me while I was refactoring. That's actually so nice. I was just refactoring some stuff and somebody like solved the problem for me. Yeah, there we go. So, thank you. Cool. So, and I also want to rebuild everything here. Yep. Okay, and yep, it works now. Thank you so much. Who said that? Trust 9-year-old. I guess. Is that how you spell your nick? Oh, it's actually 0, I see. Trust. There we go. Cool. So that's actually pretty cool, right? So there's that, and yeah, we can now interpret the same value 4 different ways: as a pointer, as a floating point, or as an integer, unsigned, sign, whatever. Did you put multiply there? Oh shit! Yes, I should have actually put plus here. I'm an idiot. I'm getting tired, I suppose. All right, but the result is still the same. It doesn't matter. The result is still the same. Alrighty. Yeah, exactly, Jack. If it compiles, it works. Cool. So what we need to repeat here is essentially minus situation, right? Minus. And it's going to be just the same as plus, but minus. Then multiplication of our nation. Mult f, but like this. And mult div f, but divide. What's interesting is that this time I don't have to check for 0, right? I don't have to check for 0 because division by 0 produces none. So I don't have to worry about that. Do I have the name for all of the operations? I think I do have the name for all of the operations. So, okay, so this is kind of similar. So I have to do size t right here. You can make them macros, etc. at tokens. Oh yeah, probably I can. We'll see. I don't want to over-engineer it yet. We'll see how it goes. So what I was wanting to do, I wanted to test something pretty interesting. 1, 2, 3, F, bosom. Then I'm gonna push 0, div F. That's what I want to try to do. Div F. Okay, so if I try to compile the examples, and we don't have instruction div F because our assembly doesn't support that. So bosom translate. I think what's translate? Yeah, I should have actually called it bosom translate source, but it is what it is. Whatevs. Yep. So this is a plus F, and we're gonna replace it with div F. Cool. Now it does work, and if I try to disassembly 1, 2, 3, F, BM, yeah, there we go. We have div F, push 0, and yeah. What's interesting is that I'm pushing a integer literal here, right? But integer 0 is the same as the floating point 0, so I don't have to worry about that. So I can even confirm that. I can try to do something like this and rebuild everything and just show you. See, it's still 0 no matter what it is. So I can just use the integer one. Yeah, if I rebuild everything, push minus 0. I can try to do that. Look. Yeah. That's -0 for you. But it's probably gonna work. So yeah. Okay, so let's actually try with 0, and let's see if it's gonna produce like none at the end of the day. So here it is, and let's try to interpret this. BME, and of course the input has to be defined like that. And, a legal instruction. Did something fall through? Did something fall through? I feel like something fell through. Well, yeah, we have two values on the stack. The value and 0. Apparently div f is an illegal instruction, and I wonder why. Div f. It feels like something fell through. That's what it feels like. Okay, minus break, motive div break. I don't see anything wrong here. So why did it fall through? Maybe, oh, okay, I know what it is. I probably forgot to recompile everything. That's probably what happened. Yeah, I forgot to recompile everything. Okay, so yeah, as you can see, the result of everything is infinity. So this thing turned into infinity. Very cool. If you want to succeed in game industry, you know, so yeah, everything seems to be working. Everything seems to be working. Everything seems to be working. That's pretty cool. Okay. But if you try to divide like by integer 0, it's not gonna work. We will try to do something like this. Push 0, and if you divide 0 by 0, it should be none. And also examples. Yeah, it's actually minus none. Everything seems to be working correctly. All right, so we want to test other things. So what about -0? -0, right? What about -0? What's going to happen in this case? And, well, it became minus infinity. So everything seems to be okay. It's not none, it's minus none. Yeah, I guess. So overall, so I could say it's a success. It's pretty much a success, but we need like a proper test for this entire thing, chat. I think we need a proper test. I want to implement like a method that calculates pi, at least like something super simple, not too complicated, and just add that to the samples. Yeah, what is that? I have no name. I don't know what that means. I'm sorry. All right, so let's actually try to compile that, to commit that. Push point. Yeah, probably that's a good way of doing that. So what did we do here? We implemented all of the floating point operations. Yeah, something like Newton, but I forgot how to do that. This is a Debian running inside of Linux. Ah, okay. So implement floating point instructions. Let's push that right into the repo. Okay, cool. What we need to do now? Pi calculation methods. So 5 ways to calculate pi. Something like Taylor series or something like that. Nice one. Thank you, WikiHow. Very cool. Just do the Taylor series. I don't know how to do them. That's the problem. Taylor together with the okay. This formula is the most easy verified using polar coordinates. Okay, pi Taylor series. Approximations of pi. I just want to like a formula that I could encode. Taylor. Like I don't know how to encode that. I don't remember how to do Taylor series. That's the problem. Okay, pi divided by 4. Okay, I see now. So you need arctangents, right? So, but we don't have arctangents. That's the problem here. That's the problem. Monte Carlo method is interesting idea. So is there something that does not involve the trigonometric functions? Continued fractions. This is better. We can use something like this, probably. We can use something like this. Besides the simple continued fraction representation, well, we can approximate arctangents with Taylor series. This is how we use Taylor to approximate pi. Okay, but I need a method that I could just encode. I don't want to spend time learning how to do that, so that's the problem. I want to be able to click on the Taylor series and you know, just see how you do that. So I'm not a mathematician, so just waste of time for me, unfortunately. Okay, pi calculation with Taylor series code. Taylor very slow. Yes. Holy shit, that's so useful. Okay. I'm trying to implement. Cool. Is there any ready code that I can just translate? I just need a code that I can just translate without anything. Math, is that a debate? Is that a debate? Is that a debate? Probably a debate. Probably a waste of time. Holy shit, it's so slow. Okay. For arctangents. I see. So arctangents x. Okay, that's actually good, I think. It's actually quite unbelievable how some people completely miss the point of what I'm doing. It's just unbelievable. Holy shit. Okay, so let's see how we can implement all of that. So pi is equal, so we need to do arctangents 1, right? You can write pi like this, pi equal to that. It's basically 4 multiplied by arctangents 1, if I understand. This is 1, right? This is definitely 1. So we're gonna start with 1 then, and it's gonna be like this. Right? Calculate E approximated. Okay, this is exactly what I'm gonna do here. Thank you so much. So 3, 5, 7, and this is to what degree we want to do all of that. But the question is, can we have something like push 10? So this is going to be like the amount of iterations that we're going to have, like iterations. This is initial x, right? This is initial x. This is initial x, and we also need this -1, right? We also need this -1 to keep track of. That's a lot of things to consider. That's a lot of things to consider, but maybe that's okay. So essentially what I'm thinking is we need to keep track of these three components here, right? Just keep track of these three components, and the first one is going to be n, right? The first one is going to be n. So this is going to be n. The next one, it's a sign, right? It's a sign, and initially it is 0. That means it's going to be just 1. So this is minus 1 to the power of n. And another one is going to be 1 as well, right? It's going to be 1 as well. X1, so you don't need to poll. Well, yeah, I guess. In case you didn't notice, he wrote that the factorial in n is redundant. Factorial in n, factorial this one. Okay. Okay, that's actually good, I suppose. Because then we can recalculate this value ourselves at any point. Okay, cool. So this is like we're actually trying to use this machine for the first time, which is cool. Holy shit. I want to make a team. So, does anyone have any questions while I'm making a cup of tea? You can ask anything. Yeah. While I'm making a cup of tea. To be fair, I'm not sure if I really want a cup of tea. Maybe I had enough today. Yeah, I think we can try to do E. It's a good idea. Yeah, because this one is kind of complicated and may take too much time. So let's try to approximate E first. Thank you so much. I wonder how exactly we're going to implement that. So this stack machine doesn't really make it super easy. So let's do E bosom. Right, we're gonna start with pushing the value, right? Pushing the value. And 1. So this is gonna be a loop, right? And essentially what I'm trying to do here is I'm trying to duplicate the current value and increment it by 1. So that means I'll have to push 1 and plus I, right? So take the previous one, increment it by 1, and there you go. And then we can try to jump to loop back, so that enables us with, you know, repeatedly multiplying this thing. But at the same time, so how can we approach all of this? So it's going to be 1, so I push 1 more time. And then increment it by 1, so it becomes 2. And that will repeat. Okay, so let's actually try to do something about that. I'm gonna do bosom example E, but oh my god. So the input, and then we're gonna have BM. There we go. Debosom, EBM, EBM. So that looks cool. And by the way, I shouldn't use the integers. I shouldn't use the integers. God damn it. Disgusting. Just a second. So this is what I need to do here, and I need to use flows as well. So let me do bosom, and then if I do debosom, and I take a look at the E, BM, there we go. So this is what we're pushing here, and we can try to interpret that with a limited amount of cycles, like 10 of them. And as you can see, this value keeps growing. We can try to, where it was BME, so 69 of them. So there we go, we're just generating this kind of stuff. But it doesn't have to be plus, I think it has to be multf. Yeah, it has to be multf. Bosom, oh, it doesn't know multf. So we have an opportunity to implement multf operation. All right, BM, maybe debosom should print both float and int representation, but how do I compile debosom back into ASM then? So one of the requirements we have is that whatever debosom produces has to be compilable back to the bytecode. So it's kind of difficult to achieve. At least right now. Maybe in the future we can do something about that. BM translate source. BM translate source. So what we need to do here is do it like that. Multf. Okay. Now I actually have to compile everything here. There we go. So bosom, debosom. All right, there we go. So we do multiplication and then BME. There we go. So we're wait a second. We have to increment this thing as well. I see. We have to be incrementing it then. Ah, I see. So it does have to be plus. It does have to be plus, and then we have to multiply it into this. Okay, I see. So you see, we keep increasing the value, and this is how we eventually calculate the factorial. That's what we're doing. We're calculating the factorial. So let's do bosom, debosom, just to inspect. Debosom, there we go. We have plus and multf. I wish I could like make it bigger, but yeah, I think that should be enough. Okay, and let's just try to evaluate all of that and see what's gonna happen. It went to infinity apparently. So what if I have one iteration? 2, 3, 4, 5, 6, 7. Oh, it just grows too fast. I see. That's probably why. Yeah, it just grows too fast. That's why it went to infinity. That's really strange. Yeah. So at 20 cycles, it's already like 1000 and so on and so forth. At 30, it's holy shit. Look at that. Yeah, at 30 it's this value. That's why it's, yeah, that's why it was in infinity at 69. So at 69 it was just, you know, pointless to even do anything at this point. At 50, holy sh... Wait, you can represent numbers like that in double? Wow. Precision is too low, yeah, I see. That's pretty cool. That's pretty cool. And now, so what was the factorial? What was the e? Zhejiang. So it's something some, yeah. Okay, so that's what we need here then. That's what we need here then, and I'm gonna put this into the comment here, just to know. Okay, cool. So we're doing that, right? So the problem is, after we calculated one thing, so this one is gonna be the n, right? The n factorial. And then we need to accumulate the results somewhere. We need to accumulate the results somewhere. So where is we're gonna have the result? So this is gonna be the result. Right, this is gonna be the result. Cool. All right, and can we actually... Okay, so we multiply that. I think we need a way to swap the elements from time to time. You know what I mean? Because sometimes it's just not convenient. So does fourth have swapping elements? Fourth swap. Yeah, fourth swap. I think it does have something like that. Stack manipulations. How do you swap the elements in fourth? Oh my god, this is such a slow website. Why people make such slow websites? Swap. The word swap is defined to switch the order of the top two stack items. This is what I want, actually. Dragons, yeah. So we can do dupe. Duplicates over, copies second item on top. Yeah, we kind of have over, but we have more like a general over and stuff like that. So let's implement swap. Let's implement swap. Just introduce register. I could, but I want to try to not introduce like registers yet. So dupe swap. Again, I'm experimenting. Right, I'm experimenting with things. So I want to first see if it's possible to do things without the registers, and if it's unavoidable, we can introduce registers. We can introduce the registers. All right, so we have a bunch of stuff. Debuzzer. All right. So in here, what do we have? Case instruction swap, right? Case instruction swap. Does it require any operand? It doesn't require any operand. It just swaps two elements on the top of the stack. So the name of this instruction is going to be instruction swap. Inbound to mxcom for the make. What? Okay, swap. All right. Swap. So let's implement swap and see if it's possible to do something about that. Case inst swap. BM. So we need at least two words on the stack. So if the stack size is greater than stack capacity, stack size. Greater or equal, so that means, oh yeah, okay. If the stack is less than 2, that means we have a stack underflow. So this is a stack underflow. So the next thing we need to do, we need to just swap two elements. Stack size, the first element is going to be bm stack stack size -1, and the second element we need to swap is bm stack size -2. So this is how we're going to approach all of that. This is going to be a word, and this is going to be a temporary variable, right? Once we save this variable, we can quite easily just fuck it up, and this one is going to be t. So basically, you do need registers, right? You do need registers, and swap uses register implicitly, right? So that means that swap is not really fundamental operation. Like, I think fundamentally you do need at least one register. Yeah, it feels like you do need at least one register. We can try to introduce like one register, like A, specifically for that. What do you guys think? Would one register be enough for this machine? Just like for intermediate stuff. An accumulator register, yes. It kind of reminds me of Shenzhen or something. I think you at least need one accumulator. Yeah, I also think so. So far, throughout the development, it does feel like at least one register is unavoidable. At least one register is unavoidable. So maybe we just need to implement that. And what's interesting is that something like pop, right? Something like pop could automatically push into the pop out into that register. Use swap implementation that uses Zor. Then yeah, I see what you mean. All right. So and after that, this is going to be IP +1. Right. Let's see if we can do that with the swap. Right. Let's see if we can do that with the swap. And okay. E-buzz. Okay, cool. Alrighty, so we have n, so this is what we need to do here. So this is the accumulator. This is the accumulator. So we duplicate and we implement the next one. But the thing we have to do here, I think, is the following. Right, so here is the stack, right? It's 0, 1, 0, right? And the first one is that, the second one is that. So what I need to do here, essentially, I need to swap. By swapping, this is what happens. Then I'm gonna try to dupe 1. So that will duplicate this thing like this. This will duplicate this thing like this. And then I need to divide 1 by that. Which is not particularly great. So let's actually remove it like this. So I need to push 1 like that. This will create something like this. I push 1. And then I actually need to dupe 2. So that will duplicate that one and put it here. And only then I need to do diff f, which will divide 1 by that. And there you go. You got this thing, right? You get this thing, which you just have to add to your previous value, to the accumulator, right, to the accumulator, and then you have to swap it back. Then you have to swap it back, and there you go. So this is how you're gonna approach all of that. So then, based on that value, this is dupe 0. All right, then it has to be dupe that. Then we calculate the next value, so +1, push and multiply, and yeah, that's the trick. I think that's it. I think that's actually it. I think that's actually it, boys and girls. So yeah. Does it look good? Does it look good? I think it looks pretty goddamn good. Let me try to let's recompile all of the tools in the toolchain. Right here, all of the tools in the toolchain. Then I'm gonna try to do bosom. Right. I have to actually do bosom like this. Right. Swap, and we don't know what is a swap exactly. We need to implement that for the compiler. bm.h and bm translate source. Will there be protect in future to make bosom mod for Emacs? Probably, I don't know. Okay. So what we need here? We just need swap. Swap. There we go. Should be all right. There we go. And let's try to do debosom. And do we have stuff here? Do we even have swap? Yeah, there we go. So that's pretty cool. That's pretty cool. And let's try to evaluate that BME. Let's try to evaluate it once. So here's the result. Here is another value. We put 1. Then we put another, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going somewhere. Huh. It's very interesting. It's doing things. I'm not gonna lie. Okay, 69. How about 69? 100. Holy shit. Okay, so 80. What is the value of E? E constant. I forgot what's the value of E. It's not correct, by the way. Well, 81. I don't know at which point I have to stop, to be fair. So it's kind of difficult to know when to stop. Right, so it's definitely not really going well. It's definitely not really going well. Yeah. It's not gonna do much, because at some point it hits infinity, so it's not really that particularly useful. So I did fuck up somewhere. So I suppose, like, I need to clearly understand what this thing means, right? This means 1 plus 1 divided by 1 multiplied by 2 plus 1 divided by 1 multiplied by 2, 2 multiplied by 3, and so on and so forth, right? So this is basically what we have here. And this is exactly what I was trying to encode, and it didn't really work well. N starts at 0. Okay, so maybe that was the problem here then. Oh, okay. Oh, that explains it. It should be 269, and it turned out to be 116. Okay, I see what's going on. Okay, thank you so much. So we have to have 2 zeros there. So let's do bosom. It's not debosom, actually, just bosom. Okay, debosom. Alright, so we push 2 zeros there, which is exactly what we want. Alright, and then BME And let's actually do 100. 10. 2. What's going on? Huh. Something's really strange going on. Bosom. Another one. Bosom, please. Okay. And BME. Alright. 2, 3. Yeah, 0 divided by 0. Yeah, okay. Maybe. So yeah. I see. So essentially, you're gonna have like this thing. Yeah, this is what you're gonna have. This is what you're gonna have. If it's 0, yeah. So another one is also gonna be 1. Yeah. So okay. That makes sense. That makes sense. Let's compile the bosom. So it is in fact correct. It is in fact correct. And let's do BME. 4, 10. Well, we're going somewhere. 25, 30, 60, 9. Well, yeah, as you can see, it's going places, but I'm not sure to what extent, right? It just doesn't really improve over time. It's just 269. Yeah. Yeah, it doesn't really improve over time, but 100. So, but it's kind of close, I think. The factorial is probably overflowing. Yeah, that's probably what's happening. So we need to be able to step by step, I think. But I mean, it's actually pretty close to what we want to have here. So because our goal is to... Is floating point supported yet? No, we don't support floating point. We're not going to support it. Let me try to add a special flag to BME, which allows us to step debug. Okay, so it's going to be -d, right? Step, let's call it debug. By default, it's not. And something like else if strcmp, if we have a flag -d, right? If we have a flag -d, we do debug true. Well, debug true. That's what we do. And essentially, we execute the program, right? And program execution is actually kind of hidden from us, which is not particularly great. So, yeah. If not debug, we just use this kind of execution. Right, so this is a not debug execution. And debug execution is going to be slightly different. So we're going to emulate that loop ourselves. Alright, we're going to emulate that loop ourselves, and if we have an error of some sort, we're going to print that error. We're going to print that error, and also we have a limit here, just in case if you need that limit. And that's what we're going to do here. We're going to dump the stack and wait for the user input. We're going to wait for the user input. And how can I just read the line? Is there something like read line? I think we can, well, it's actually part of the read line. Get line, is there something in C? I forgot if there's something in C for that, like get line, just wait, fgets, maybe we can do fgets, but for fgets it feels like we need to provide something. Like we need to provide the buffer, but I don't want to allocate the buffer. We can try to, because why not? So what if I provide like a null pointer and they say that the size of the buffer is 0 and then I read from std? Is that a thing I can do? Is that a thing I can do? That would be actually pretty cool if I could do that. Okay, so bm halt. Alright, so that's what we have to do here. Execute instruction has to be a pointer. Okay, it looks cool. So now if I try to do bme, and instead of providing that, I'm going to provide this, and unknown flag. Did I forget to rebuild shit? It has to be an unknown flag. It's minus D. Yeah, it is a known flag. What the hell are you talking about? Right. Oh yeah, classic. Illegal instruction access. Is that because I forgot to load the program in BME? Yeah, so I first have to load the program. Alright. It doesn't stop. Okay, fgets doesn't wait for anything, that's the problem. Fgets doesn't wait. But can I... Oh my god. And it's segmentation fault. Okay, so this is what we can do here. Char. We can do get char probably. Let's try get char. But I'm sure is get char even a thing in standard? Get char. Yeah, let's do get char. Such a simple thing. Just want a simple thing. Yes. Alright. Okay, so that's what's happening here, essentially. So this is how we keep calculating this shit. And at some point, I suppose, it should start overflowing. I feel like the division is scuffed slightly. That's cool. So... it's doing things and shit. It doesn't seem to be overflowing anything. I think there's like a mathematical mistake. Maybe I divide n by 1 instead of 1 by n. Because they never become fractional. Notice how they never become fractional. So that's kind of the problem here. I think I'm just dividing something incorrectly. In any case, I think we need to commit this like debug thingy, because it's definitely useful. Okay. 10. Introduce step debug mod for BME. And I'm gonna push that right into the repo. You divide 1 by every big number and get very small number. That's why. But I don't see small numbers. I see. Like, where are the big numbers? Okay. Okay, so here's the fractional number. Okay, so that's kind of correct. Okay, so we do at some point get small numbers like this one. So it's fractional, so that means we do divide 1 by n. 4 iterations should already give you 2. So that means I'm doing something wrong. Okay, so we're gonna try to investigate what the fuck is going on at some point. Well, that was weird. Look. Well, I mean, no. It's actually okay. Okay. So... Okay. And it becomes 0. Yeah, I see. Yeah, something very fishy. Okay, so what do we need to have here? So I want to introduce also swap operation. Yeah. Introduce swap instruction. Swap instruction. I'm gonna push that right into the repo. Check factorial implementation. Yeah, I think something is fucked up with factorial. Okay, cool. Bosom. Okay. So that's what we need here. So this is the sum, this is that. All right. So I want to copy paste these things like so. Okay. All right. So what we do, we swap these things together. Then we push one. Then we duplicate 2. So 0, 1, 2. So that's what we duplicate. Then we divide. So effectively we divide 1 by n thingy here. So which will result in just 1, of course, in just 1. Then we sum it up with the sum, right? Then we sum it up with the sum, and this becomes 2, which is that, which is okay. And then we swap it, right? Then we swap it again. There we go. So here is our sum. This is our new sum. All right. So the next thing we do, we duplicate n, then we push 1, 0, then we sum it up. So this becomes oh, I see. So we need n factorial and n separately, I think. That's what we need. We need n factorial and n separately. Okay, so that requires implementing like everything from scratch. I see now. So so n factorial and n separately. Okay. All right, let's try to implement that one more time. So n is 1, and because of that, this one could become like 0 or something, right? So we can try to initialize them like this to not break this piece of code, right? If we initialize them like this, we don't have to break this piece of code. I just realized that we need to change the title of the stream chat. Coding in assembly for my VM. I think that's actually way better than what we had before. Okay, so so I'm pretty sure this will this arrangement is not gonna break anything, which is kind of cool. And so that means on the next step, what we need to do, we need to duplicate not 0, but rather 1. No, 0, 1, 2, 0, 1, 2. Duplicate 2. Cool. Right. Then we push 1. Then we plus f it, so plus 1. Cool. Becomes 2. Then we multiply them together. Essentially, we're multiplying this thing like that. And there we go, we have a next thing. But now, how the fuck do we update n? So that's the problem. How the fuck do we update n? That's a good question. Yeah, stack is Pepega. Stack makes it kind of difficult to do these things. So this is where we're starting to hit this like a wall with purely stack-based machine, and it definitely would be useful to have at least like 1 register or 2 registers or something like that. So yeah, some point we'll have to redesign all of this, but that's why I told you about sec_d. I have no idea, like I don't even remember what you told me. What you think I read chat? Okay, so let me see. Is there any way we can approach that somehow? So if we could, like if we had at least one register, we could temporarily save it to the register and then swap these things, increment and put it. Yeah, we need like some sort of a temporary register. Now it's a tower of Hanoi swap. Oh, by the way, what if we had 2 stacks? By the way, are 2 stack machines a thing? Does anyone know? Are they a thing? Or does anyone watch me right now? I'm not sure. Is everything okay? I'm not sure. Okay, so 2 stack machines are a thing. So yeah, we can think about 2 stacks. But to be fair, for now, to implement this algorithm, we need at least 1 register. To remove value from a stack and put it to the top? Probably. We can try to do that, at least for now. But then we'll have to put it back, so that's the problem. We need to be able to put it back. Right, so how are we gonna put it back? So steal instead of dupe. Yeah, could be. I'm just thinking what would be the easiest thing to implement right now to make this algorithm work? What would be the easiest thing? Because we'll still need to put n back to its place, to its original place. So that's the problem. Wait a fucking second. What if swap accepted an operand? Okay, we're gonna see if that's a divine intellect. Let me show you. Swap is gonna be like dupe. You see what I mean? Swap accepts operand as dupe, and that operand means the same thing as in dupe. Guess what it means? It's a relative address starting from the top, and you can swap with any element down. Holy shit, this is a divine intellect. Okay. Oh my god, yes. I'm sorry. Okay, so swap accepts an operand. Swap accepts an operand. You joined at the right moment. Yes. Yep. By the way, we do need this thing here. Weep streamer, no. Mod. Ban weeps. Permaban. Where do I even start with all this shit? Oh yeah, bm translate source, right? So swap, and what we're gonna have here, we have to accept the same shit as dupe, right? The same shit as dupe. So that's how we're gonna do that. I know that there is a lot of duplicate code, but bear with me. I'm Russian. This is the worst pun I've ever done in my entire life. Holy shit. Okay. So, how do you implement swap? Yes. Please, no, no. Jiangu-sama, please, no. No unsubscribe. So we have stack overflow and stack underflow. So this is exactly what we can do here. Well, we don't really have like a stack capacity or anything. So yeah, this is what we need to do here. Yep. Stack underflow, and what we're swapping here essentially. So swap 0 is not gonna do anything. So swap 0 is not gonna do anything. Swap 1 swaps the top 2. Swap 2 swaps these two things. So this is such a useful operation that you can probably sort the stack at some point using that. Okay. Oh shit, my brain doesn't work. Don and Sam, please, he's not going to let me out the basement otherwise. Yes. Okay. So this is not a thing, by the way. This is not a thing. And yeah, the way it has to work. This thing has to be less than the size. Right, it has to be less the size. If it's greater or equal than size, you're not going to be able to do that. So, and we need indices, uint64a. So what we're swapping here, we're swapping index that with minus the operand itself, right? Minus the operand itself. Holy shit, some people just don't understand. It's kind of funny how like people get like timed out for sending links and they just can't fucking stop. They just cannot stop. Like, just no, I have to send that link. Mr. Streamer has to see the link. Oh my god. Holy shit. It's just amazing. It just amazes me every time. Okay, so if this is 0, this is how we're gonna swap all of that. Alright. Is that good? Is it good enough? Is it good enough? Probably good enough. Naizu. So let's actually start over yet again. So we have this situation, right? So we have this situation here, and n, we need to increment the n. So what we need to do here is swap, right? 1, 2. We need to swap 2. First of all, when we swap in before, we actually were swapping 1, right? We were swapping 1. Now we're swapping 2. We're swapping 2, and how do we even swap this thing? That's what we do here, actually. So we just swapped it. Then we push 1. So that gives me 1. Then I do plus yet again, and that increments n, and then I can do swap 2 yet again, which swaps these two things like that. Holy shit, this is a divine intellect, chat. Yes. I kind of want to start over and re-implement everything considering swap with relative addressing and shit like that. So I'm gonna start over. So this is our initial thing. Right. Okay. So at n1, n thing has to be that. This is the sum and everything. So this is the sum, this is that. Okay, cool. how are we gonna do all of that? I'm gonna start by I guess pushing, maybe pushing 1 onto the stack, right? Pushing 1 onto the stack, so here's 1. Then swap 1, which will swap these things together like that. Then div f, so that will divide, and we're losing n. Yeah, this has to be actually, we have to be very careful. We don't want to lose n. Yeah. So that means that this particular case we have to duplicate 0, right? We duplicated 0. Then push 1. Then swap them together. So swap swap 1, right? Like this. Then divide. Div f. So that gives us 1 over that thing. 1 over that thing. So the next thing I want to do is probably is there any better way to organize that? Maybe. Yeah, so what if we organize it like that initially? So it's going to be n factorial, and sum. n factorial, and sum. So let me see. Is that a better way of doing that? Let's find out. So I can do something like dup 1, right? So that means I can duplicate it like this. To be fair, I can do it differently. I can first push 1. I can first push 1. Right. First I'm pushing 1. So this gives me 1. Then I can dupe 0, 1, 2. So this is 2. That means I'm gonna get this thing. And then I do div f, which gives me 1 over that. 1 over that. And then I can do plus f, which gives me, yet again, something like this. You see? So, and we're back at this kind of situation, right? We're back at initial state. Then what I need to do, I need to increment all of this stuff. So what essentially I want to do, I want to swap with what? Swap with 1, I suppose. 0, 0, 1, 2. So we're swapping with 2. So it's gonna be like this. Huh. Okay. But do we really need to swap with that? Yeah, I think we do. So, okay. Then I push 1. 1. Then I sum it up. And what I get, plus 1. Cool. But here's the problem, right? If I duplicate it right now, I won't be able to easily do all of this, right? If I swap them, swap 1. Okay, if I swap 1, I'm gonna give that. No. Okay. So I incremented this thing, and now I need to increment this thing as well. I can try to duplicate 1. Okay, sure. I can try to duplicate that. I can try to duplicate that, and then I can try to swap these two things. 0, 1, 2. So I'm gonna do swap 2. which effectively will do something like this for me. And then I can just sum it up. And what we have here is effectively this thing. But what's interesting is that now we need to go back into this order. And how can we go there? So sum should be here, so that means I have to swap 0, 0, 2 like this, and that is not correct. Yeah. So first I need to swap 1, and then swap 2, which will result to this. I think that's it. I'm not sure if I made any mistakes, but we can try to go through this program yet again just to see if it does perform what we expect it to perform. Well, let's try to do that one more time. So I'm not going to design anything anymore. I'm just going to go through the algorithm and see if it does what I expect it to do. So push 1, push 1, dupe 2, 0, 1, 2, duplicate it and push it here. There we go. Divide it. So this thing will give me 1 over this thing. Sum it up. This thing give me this thing. Okay, this thing give me this thing. As a matter of fact, I could probably just do something like this. Okay, swap 2, 0, 1, 2. Push 1, 1. Sum it up. Let's actually put it like that. So this is the pointer. Sum it up. Cool. Next, dupe 1, 0, 1. Swap 2, 0, 1, 2. Okay. Oh shit, did I fuck it up? I think I fucked it up. I think it has to be 0. Thread plus should be multi. Who says that? Okay, well, okay. I see. Dupe 0. Which one? I have 2 dupes here. So you think I have to have dupe 0 here? Okay, I need to go one more time. This is hard, chat. Okay, that's supposed to be hard. First of all, this is supposed to be hard because it's assembly. Oh shit. Right, because we're working with a really low level shit. Okay. Second one. Okay, push 1, duplicate 2, 0, 1, 2. Duplicate it on top. Divide it like this. Plus like this. Swap 2. 0, 1, 2. So we swap this thing like this. Put in this thing here. Push 1. 1. Sum it up. Duplicate. Swap 2. 0, 1, 2. It's like this. 0, 1, 2. Multiply like this. Okay. Swap 1 like this. Swap 2 like this. N factorial sum. We did it. Yes, we did it. It works. Single iteration works. Holy shit. Oh boy. Oh boy, oh boy, oh boy. Just add registers. Sure, I think at some point I will add registers. Okay, so does it compile? All right. So as already mentioned, this is an experiment. I just want to see if it's possible for us to not have a resistance. So I just want to see that. Rub the head for good luck. Yes. All right. So is it gonna be first try? Is it gonna be a first try gut cooter? All right. So and examples. Cool. First I need to do bosom. Examples. Is it in examples or is it in E? E bosom. It's located in examples. Cool. Because I forgot already. I've been there for so long. E bosom. Actually, I want to take a look at D bosom. Okay. Sorry. Okay, so here's our program. We do have swaps. I wonder if they work the same way as I want them to work, but anyway. A BME input step debugger. Stack on the floor. Fuck. I would presume that stack on the floor happens somewhere in a swap. So swap. Let me double check. Yeah, it's in a swap. Okay, so at some point, operand could be equal. Like no, it shouldn't be. Well, 0. A greater or equal, but it's a stack size. No, 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 no. It's a stack size. No, 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 no. Because and then we're subtracting this thing. No, no, no. Greater? It shouldn't be greater. Come on, because it's relative to the top. I see what you mean. I'm an idiot. Holy shit! My logic is reversed. I'm sorry, Jiang. Oh, holy shit! I'm sorry. I'm sorry. Oh, I'm already tired. So. I'm sorry. I'm sorry, Jiang. Okay. It's kind of difficult to tell. So where is the result? I literally cannot see it. I see. Look at that. Yeah. It's not correct. It's somewhere there. Oh, by the way, let me remove that. I think some should be already because we skipped N0. Yeah, we skipped N0, and this is quite important. Yeah. All right, so let's try to do it like this. I'm gonna like do it for 69 iterations, and I think I forgot to recompile the. I think. Oh my god, come on, come on, come on, come on. Boson, example E boson EBM, BME, 27, how about 100 of them? 100 didn't really work well. Yeah, boy. Yes, chat, we did it. We did it together. Well, I think it's at some particular point, like it doesn't really make much sense, but there we go. Here it is. Here is the E number. We are calculating it. It would be kind of cool to also check for some stuff, I think. Let me see. After all of that, so we have n, like at this particular point, we have n here, right, at the top, which means we can do dupe. We can do dupe 0, 1, 2, 0, 1, 2, and we can also push. So this one is actually a number, and we don't have a equality for we don't have equality for doubles, but I think it's gonna work. I think it could work. Where do I get the VM? Yeah, thank you so much. And I can push like something like 69, right? And then I can try to do equality. It's gonna compare it by bits, and it's kind of dangerous. But yeah. So if it's equal, it's gonna be 1. So we need negation. So maybe something like not, or yeah, not. And jump if. That's what I want to do. You see what I mean? Maybe you should add names for pushes to easily debug what the value is. How does it solve any of the problems that I'm talking right now about? Irrelevant comment. Okay, so let's actually introduce inst not. Okay, so what do we have here? So does not accept any arguments. Doesn't accept any arguments. Okay, so, and also we're gonna have something like this, inst not. Come on, Emacs, you can do that, I believe in you. Enumeration value not handled. Okay, so I can do something like that. Alright. Another one. Not. Let's implement it. Case inst not. If inst operand as you. This one is interesting. How do we implement jump if? Jump if. Yeah, we'll literally use it like that. Okay, cool. Jump. Okay. If BM stack size. If BM stack size is less than 1, stack underflow. BM stack underflow as U64 BM IP +1 break. Cool. That's pretty cool. So we are inverting all of that, and cool. And if I try to do boson, it's not gonna compile because first of all we don't have equality operation, BM translate, and second of all we don't have not operation. We're gonna implement all of them. So equality doesn't require any operands. Cool. And not also doesn't require any operands, so we'll just paste it like that. Zozin, why don't you just abstract away these if-elses? Why don't you do that already? Why your code is not finished? Okay, jump if. Jump if is actually very interesting because it's the same as jump, but with if. So it will require resolving the labels. It's quite important. It will require resolving the labels. So here's the jump if, right? And I put it like that. And what's interesting is that our label resolution mechanism is general enough that you can just add it like that. This is actually amazing. I really like that. So you just copy paste this thing and it will be a part of the label resolution mechanism. It's kind of cool. And there we go. So after that, I should be able to do debusm, EBM, and there we go. And we have jump if that jumps to the third one, 0, 1, 2, 3. And I hope it is a correct way of doing that, because you have 1, 2, 3. Yeah, so it is correct. It's actually correct. So the labels got resolved correctly. All right, so the idea of all of that here is that if n becomes greater at some point, we'll have to your jump if pushes a deferred address and then jumps before it. No, it doesn't. I don't know what you mean, but I don't think it works the way you described. Jump if works. You can actually look up how it works. It's in the code somewhere. So jump if. Yeah, this is how it works. So it basically. Yeah, it takes the argument from the stack, right? It takes the argument from the stack. Oh, this is actually kind of bad. Thank you for telling me that, because it has to consume the element always. Okay, that's actually cool. So thank you for bringing my attention to this thing, because it's kind of weird. Right, we check this argument and then we jump, but we have to decrease the stack because, I mean, we consume the stack. Yeah, I see what you mean, thank you. All right, so we can do bosom and we can try to do BME now. And let's see if it's gonna continue at some point. So what's gonna be the limit here? Let's set the limit. We can try to set the limit so it's 69. What about 1? Let's see if we can do at least one iteration. N is, oh yeah, so that means it has to be at least 2. Right, it has to be at least 2. Let's do bosom. Right, it's gonna be bosom. Debosom is EBM. EBM, everything looks okay. So we push into here, okay. So BME input EBM step. Okay, we're initializing everything. So the state of the program got initialized. Cool. So we're calculating the next stuff. And I have a feeling something didn't really work well, because it keeps incrementing this stuff, so it didn't really work out. Yeah, it doesn't stop. It doesn't stop at all. So our condition just doesn't work. Our condition doesn't work at all. So what would be better, in my opinion, right, is just something like push this, and then once we pushed that value there, well, to be fair, we could do something like, there's going to be daily series, not really. Tomorrow we're going to try to do something else. Okay. So I'm doing equality here, but then I duplicate this thing, and then I duplicate this. Then I push this thing, and what I'm gonna do here, I want to check greater or equal F, right? Because we need floating points to compare this properly, and it's gonna be Jeff, and so that means we can do, we don't even need not here. Duplicate 2, so 0, 1, 2, you duplicate that, then you push 2, and if it's greater than equal, is going to be that, and yeah. So the only instruction we need to implement here, chat, is a GIF instruction. Let's see if we can put that here. So instruction GIF, it's like greater equal, but for floats. Make sense? So let's implement all of this stuff. It's gonna be GIF instruction. Doesn't accept any operands. The name of that instruction is gonna be, of course, is gonna be GIF. It's pronounced GIF. Yes, it is pronounced GIF. That's the official pronunciation of this instruction. GIF, the instruction. Greater equal float, that's what it stands for. Come on. Do you even watch the stream, Nuffly? Okay. So it's a GIF, right? And what we do here, first of all, we interpret them, like this, as f64 greater equal. If that thing is greater or equal, then we put it back into this thing and we decrement the stack and so on and so forth. Yeah. All right, so let's see, and we also need to translate source. It's like I explained what this instruction does like a second ago instantly. What this instruction does, like, come on, dude. Do you watch what I'm doing? All right. So this is going to be EQ, GIF instruction. Cool. GIF the instruction. Bosom. Is it going to work? Yes, it does work. Debosom. Do we have GIF the instruction? Yes, I think we do have a GIF the instruction. Cool. So we have to perform like 2 iterations and whatnot. All right, so let's see if it's gonna deliver on that part. So I want to recompile all of these things and also, holy shit. Okay. I don't know what happened, but I think it's a pretty bad sign. Please tell me that it's gonna work first try. No, didn't work first try. Illegal instruction access. Oh, okay, I see. I forgot about the halt. So basically it went through and it didn't have any stop here. So it's just, yeah, that's what happened essentially. Maybe we don't need halt. Maybe we do, because sometimes you need to end prematurely. So that's actually kind of a thing that you have to do. All right, so now BME. There we go. And at some point, it's gonna start doing these things, right? And it stopped. Cool. So the reason why I'm doing all of this shit, by the way, chats, the reason why I'm doing all of this shit is that after we are done, we have a sum here at this point, and I want to print debug this sum right here. So before halting, I'm print debug this sum, and when we do print debug, how do we even interpret it? Wait, let me find print debug. So we interpret this thing as you. Okay, this one is actually kind of okay. Dump stack. This is how I think we need to do that. Print debug. Come on, find this, please. Okay, so this is how we're gonna put it. Cool. So, but instead of this thing, it's gonna be bm stack size -1, like this, and this is gonna be std out. So it's gonna print only the this stack thingy. Bosom. It's not. I want a bosom. Print debugged. We don't have that instruction. Cool. And translate. We're almost there, by the way, chat. We're almost there. Don't worry about it. So inst not is going to be instruction print debug. Cool. Alrighty, and I want to do bosom, then debosom. There we go, we have everything, and at the end of the loop we have print debug. So, and we can do something like this, BME without step debug. Okay, so I think BME has to be slightly different in my opinion. Maybe it shouldn't print the stack after the execution. Let's actually not print the stack after the execution. There we go. So a single iteration of E calculation, a single iteration gave us 2.5. Now pay attention, chat. We're done with this thing. So now I can control how many iterations I can do within the program itself. Within the program itself, like I have one iteration now. How about 3? How about 2? So I'm gonna recompile this thing, right? I'm gonna recompile this thing, and I'm gonna try to run it. You see, I don't set any limitations within the emulator, and it stops, and the number is getting closer to E. So if I put 69 iterations here, right, 69, and recompile it one more time, and then BME, I'm not setting any limitations. At some point, it's getting closer to E. You see what's going on here, right? So now we have enough power within the virtual machine to actually stop at any particular point and print the result. So yeah, we have loops, we have conditions, we have like comparison. So this is why I needed this Jeff operation and so on and so forth. So this is actually pretty cool, right? And this is like, yeah, how about like 100 of them? Let's do bosom, right? And it all compiles, and then BME. Is that correct? I think it's not particularly correct. 8280. I think it's actually kind of correct. Well, I mean, it's on point, I would say. Like, I mean, the Wikipedia doesn't give us enough precision. That's for sure. But yeah, that's cool. Look at that. Let's actually have like a program that calculates E. Thank you so much, Jiang, for suggesting to do that. I think that's actually super cool. Okay, so but here's the thing, like this thing kind of ruins this entire stuff. I think I'm gonna keep it here. So BME, what we did here, we added a bunch of instructions here. 10 add not and Jeff instructions, cool. And the next thing we need to do, we need to add E to the examples, to the build, right? So we're gonna be building E, and then I'm gonna do it like that. Query replace 123F with E, boom, and what do we have here? It seems to be, how about examples? So if I try to build the examples, it built all of the examples, and maybe it makes sense to add that to the examples here as well. BME, E, examples, E, BM, without any, limitations here. So no limitations. Holy shit. So that's strange. But this is because oh yeah, I see what's going on. This is because of that thing. Ah, goddamn. Yeah, we need a prettier way of doing that, but overall that works out. It's just, it also prints the state of the stack at the end of the execution, which doesn't really help that much, right? So it's just really strange. Yeah. Okay. Add E calculation example. Let's push that right into the repo, and you can find the source code right here, right now, right here, right now. How about that? So I want to actually do git clean fdx. git clean fdx and rebuild everything from scratch just in case, and all of the examples, everything builds clean. Now, so yeah, we implemented separate instructions for floating point arithmetics. That was interesting. That was definitely interesting. And let's create a pull request chat. Maybe we don't really need to do that, but yeah, let's create it anyway, even though we don't have a CI. Okay, and add floating point arithmetic instructions, and this is gonna close issue number 10. And that was actually pretty productive, chat. That was actually pretty productive, not gonna lie. Holy shit, look at that. That's actually bigger than my usual pull request threshold. Is actually over by like 90 lines, but I think I'm gonna accept that because that like the project is at early stages. It requires a lot of changes. Everything is changing. Yeah, that's why we kind of like sometimes need to go over that threshold. But yeah, now we have floating point arithmetics. We have pretty useful operations. I'm especially proud about swap operation because it's actually more abstract. It's more general than the swap in fourth, right? Because you can swap with any element at the stack, which kind of makes it so we don't really need any registers, right? So because essentially you can have, for example, n variables, and at any point, if you want to access the ith variable, you just swap with that variable, work with that variable, and swap it back. So it kind of implements like random access on the level of the stack. Well, the top of the stack is now the implicit register. Oh, that's a good point. I didn't think about it. Yeah, I didn't think about it this way. Yes, technically the top of the stack is the implicit register. Yeah, and I'm actually okay with that. I think it's actually a pretty interesting idea. We can go with that. Yeah, cool. So, all right. Today's stream was pretty productive. We implemented a lot of shit. Let me see what exactly we implemented today. Oh my god. So 4 hours, 5 hours. Yeah. We discarded the idea of NAND boxing, and we were primarily working on the floating points. Yeah, we were primarily working on floating points. Advent of Code got you used to 5-hour streams. Maybe. It's actually pretty good that I got used to 5-hour streams because I wanted to start streaming longer. For quite some time already. And yeah, thank you Advent of Code for training me to stream for longer times. Okay, it is time for me to go, boys and girls. I think today was a pretty productive stream, but again, it's time for me to go. So thanks everyone who's watching right now, really appreciate it. Have a good one, and I see you tomorrow. Tomorrow we don't really have anything according to the schedule, but since Advent of Code was such a cool event, so I decided that every Thursday we're gonna be doing Advent of Code, but previous years, right? So tomorrow we're gonna start solving Advent of Code into 2019, and the challenge of 2019 is gonna be solving the Advent of Code entirely in Haskell. No matter how difficult the problem is, no matter how much it requires mutable state or arrays or tables, it has to be solved in a purely functional language, Haskell, which sounds doable actually. I think we can do that, and I have enough experience in Haskell to actually pull that off. So yeah, the challenge for the 2019 years is going to be completely in Haskell. So we'll see how it goes. I don't know how many days I will try to solve, so since I don't have to worry about spoilers, I can actually solve 2 days in a single day, or 3. Well, I mean, at some point, like around here, we'll probably have to do like 1 day per day, but we'll see how it goes. Yeah. And also check out our schedule. I'm gonna keep updating the schedule, so I'm gonna schedule the Advent of Code Solving on Thursday. And also check out our VODs channel for more streams, because this is where we archive our streams. So I already created a separate playlist for virtual machine. If you want to start watching the virtual machine series since the beginning, you can find that that playlist there, and any consequent virtual machine streams are going to be archived there. So, and I also gonna create a separate playlist for Advent of Code 2019. We already have a separate playlist for Advent of Code 2020, so you can actually go to this repo. There is a link to Advent of Code 2020 just for you if you're interested in how we did all of that. In 2020 we did like 25 different languages challenge. It was really fun. I really recommend it. And also check out our Discord server for offline discussion with the community. And I guess that's it, boys and girls. I'm a little bit tired, so I don't think we're gonna raid anyone. So yeah, see you all tomorrow. Love you.